Hello friends, today we will discuss about network laws and network theorems. If I take this network contain resistance. Resistance means this is a linear circuit element because the current and voltage relation through the resistors is linear, and it contains also a non-linear element. This is diode. This is a non-linear circuit element. It also contains voltage source and current source. So these are called passive circuit element. Passive circuit element. So a network may contain several number of active, passive, linear, non-linear circuit element. So this network become complex, and it is very difficult to calculate the current through any branch or voltage across any resistance. It is very difficult to calculate this, or to calculate the response for definite excitation. So it can be simple by using network laws and network theorem. So by using network laws and network theorem, this circuit may be turned into a simple circuit, and we can easily calculate the current and voltage or any response for a definite excitation. So there are 2 basic network laws and 9 basic network theorems. Here you see, this is the 2 network laws, basic network laws, and that means one is Kirchhoff voltage law and another is Kirchhoff current law, that means KCL and KVL. And the 9 network theorems, one is Thevenin's theorem, number 2 Norton's theorem, number 3 maximum power transfer theorem, number 4 superposition theorem, number 5 reciprocity theorem, and 6 compensation theorem, 7 Teligand's theorem, 8 Millman's theorem, and 9 substitution theorem. So if you know these 2 laws and 9 theorems, it will be very easy to calculate any network parameter like current and voltage of a complex network. Okay, so for the next class I will discuss all the network laws and network theorem one by one. Okay, so before discussing the Kirchhoff voltage law, we have to know some network terms. What is the network terms? We should know what is node, essential node, and mesh and loop. So you have to know this network parameter, network term, related term. That means one is node. What is node? Here you see this point connect 2 circuit element. This is one circuit element and this is another circuit element. So this point connect 2 circuit element, and this point connect also 3 circuit element. This one circuit element, this is another circuit element, and this is another circuit element. Also this point also connect 3 circuit element, and if I take another point, this is D, this also connect two circuit element, and this is the, suppose this is G, this circuit, this point connect four circuit element. So this, all this point connect two or more circuit element, two or more circuit element. This point are called node. So A, B, C, D and G all are node. So what is the node? Node is a point in a network which connect two or more than two circuit element. Okay, two or more than two circuit element, this is called node. So in this network, this is also a node, 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 and this is the ground node. Okay, now you have to know what is the essential node. What is the essential node? Essential node means, here you see this node connect two circuit element, this node connect three circuit element, this node also connect three circuit element, this node is connect two circuit element, and also this node connect four circuit element. So when a node connect more than three or more than three, so node B connect three circuit element and node C also connect three circuit element. So and this B and C node is called essential node. So a node which connect more than two, that means three circuit element, then the node is called essential node. Now you have to know what is the branch. What is the branch? You see that this node is extended from this two node is connected by a circuit element, and this node is connected by two circuit element, that means one resistance and one capacitance. Okay, so what is the node? Branch. Branch is a part of a network which extend from one node to another node. This is called branch. So here AB is called branch. Also BC is called branch. Also CD also called branch, and DG also a branch, CG also a branch, BG also a branch. So branch is a part of a network which extended from one node to another node. This is called branch. Now what is the essential branch? Essential branch. What is the essential branch? The branch between two essential node. This is the essential node, this is the essential node. So this branch is essential branch. Okay, so BC is essential branch. So branch between two essential node. This is essential node, this is essential node. That's why BC is called essential branch. Now you have to know what is the mesh. What is this mesh? So this is also a mesh. So this is called mesh. this is also called a mesh, and this is also called a mesh. So this mesh, this is a mesh. So mesh does not contain any other mesh within it. That means in this case, if I take A B G A, this mesh does not contain another mesh within it. This is called mesh, this is called mesh, this is called mesh. But if I look, what is loop? Loop can be A, B, C, G. This is a loop. So A, C, G, A is called loop. So one loop contain more than one mesh. So this is a loop. This is also a loop. This is a loop. So loop means there will be another mesh within it. So more than two mesh, loop contains more than two mesh, one mesh, more than one mesh. And here you see, this is a branch. This branch contains one resistance, one capacitance, and this branch also contains one resistance, one inductance. So branch may contain several number of circuit element. So branch may contain several number of circuit element, and this connection must be a series connection. So here you see this resistance is connected with this capacitance in series, must be series connection. So any branch contain several number of circuit element with series connection. Okay, so this is the important things about network. What is node, what is essential node, what is branch, what is essential branch, what is mesh, and what is. Hello friends, today we will discuss about Kirchhoff voltage law and Kirchhoff current law, that means KVL and KCL. Here you see, this is a simple circuit, and this circuit contains one DC voltage source and several number of resistance, and current flowing the circuit in this way. The current through the resistance R1, suppose I, and at this point current will divided by two paths. Some current will flow in this way. So suppose this current and this current must be 2, and this suppose this current is I1. So the current through resistance R3 will be I minus I1, and this current will back to the DC source. So current flowing through resistance R6 must be I. So this is the direction of current flowing in this circuit. Now if current passes through a resistance, then a voltage drop will occur across each resistance. So there are some voltage drop across this resistance, and voltage drop through this resistance V1 can be calculated by current flowing through this resistance multiplied the magnitude of resistance in this way. So there are some voltage drop through this resistance R1. There must be a voltage drop through resistance to suppose V2, and there are some voltage drop through R6, that means V6, and the voltage drop across R3 will be V3, and this will be suppose V4, and this will be suppose V5. This is the voltage drop of each resistance across each resistance. So V1, here is V2 is I1 into R2, V3 is I minus I1 into R3, V4 is I minus I1 into R4, and V5 is I minus I1 into R5, and V6 is I into R6. This is the voltage drop of across of this resistance, okay, and the source voltage is V. Source voltage is V. Now, what will be the relation between this voltage drop of each across each resistance and the source voltage? So what is the relation between this voltage drop and the source voltage? Actually, KVL, that means Kirchhoff voltage law, gives the relation between this voltage drop across resistance and source voltage, and the relation between the voltage drop across the resistance. Okay, this is the main fundamental concept. So KVL actually gives the relation between the voltage drop across each resistance with the source voltage. So what is the statement of the KVL? KVL states that this is a branch, this is a branch, this is a branch, this is a branch. So this voltage also called branch voltage. This voltage also called branch voltage. Okay, branch voltage. So Kirchhoff voltage law states that the algebraic sum of branch voltage of a network, this is a network, of a network is zero. So algebraic sum of all branch voltage of a network in a closed loop, this is a closed loop, is 0. So 0 at any instant of time. So what is the statement of this KVL? The statement of KVL is the algebraic sum of all branch voltage of a network in a closed loop must be 0 at any instant of time. Okay, so according to KVL, we can write that V1 plus V2 plus V6 in this closed loop. You can write that V6 minus V equals to 0. That means I into R1 plus I1 into R2 plus I into R6 minus V equals to 0. This is in this closed loop. If I take this closed loop, then according to Kirchhoff's voltage law, we can write that in this loop we can write that V3 plus V4 plus V5 minus, this is minus, okay, minus V3 must be equals to 0. So this is the two KVL of these two mesh, this one mesh, this one mesh. So this is the Kirchhoff voltage law. So what is the Kirchhoff voltage law? Kirchhoff voltage law actually gives the relation between the branch voltage with source voltage. And if I take this mesh, then we can write that V1, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus, this is minus and plus. So in this direction all are positive, but this source volt is negative. That's why we can write that V1 plus V2 plus V6 minus V, not plus V, because the direction of current in this direction and the direction in this way. So this is plus minus plus minus plus minus, but this is minus plus. That's why here I can write that minus V, not plus V. So in this way you can write the KVL equation in a specific mesh of a network. So in generally we can write that the summation of all branch volt at instant time of t at a closed path must be equals to 0. So mathematically we can write that the summation of all branch voltage, this one also a branch, so this one also a branch, this one also a branch, so all these are branch. So summation of branch voltage at instant time of t around a closed path must be 0. So this is the main things of KVL. Now what is the KCL? Here you see this is all the branch are terminated at a node. So this is a one node. Suppose this is a node. Suppose this node is A. So here is 1, 2, 3, 4, 5. 5 branch are terminated at a node A. This branch contain current I2, this is I3, this is I4, this is I5 and this is I1. So all branch contains some current and all branch are terminated at a node A. Then what will be the relation between this branch current? Actually KCL, that means Kirchhoff's current law, gives the relation between this branch voltage, between the branch current, not branch voltage, between this branch current. What is the statement of the KCL? Statement or KCL, the algebraic sum of all branch current at a node. So what is the statement of Kirchhoff's current law? Kirchhoff's current law states that the algebraic sum of the current at a node, the algebraic sum of branch current at a node must be equals to 0. So if I take entering at the node is positive and leaving from the node is negative, then I can write that I1 minus I2 minus I3 plus I4 plus I5 equals to 0. This is the KCL equation of this node. KCL equation of this node. Now, in generally, we can write that the summation of I at a node 1, 2, 3, 4, 5, 6. So suppose the node is n node. So node at branch equal to 1 to n branch suppose must be equals to 0. This is the main fundamental things of KVL and KCL. So KVL gives the relation between branch voltage with the source voltage, and this gives the KCL gives the relation of branch current at a node, all branch current at a node. Now this is the basic things of KVL and KCL. Now KVL is based on conservation of energy. Okay, and here you see that all the entering current must be equals to the leaving current. So here from this equation we can write that I1 plus I5 plus I4 must be equals to I2 plus I3. From this equation we can write this. So the total entering current at the node must be equals to the leaving current from this node. So this node does not accumulate the charge. That means this node cannot accumulate a charge. That's why this law is based on conservation of charge. Conservation of charge. Here you see this voltage is DC voltage. So if I give a AC voltage, then it is applicable for KVL and KCL. If first of all I have taken the DC source, but if I give this source is AC source, then it is applicable. Yes. So KVL also applicable. KVL is applicable for AC source, AC and DC source. Okay, source voltage. So if I take a AC voltage source or DC voltage source at a network, then we can apply KVL and KCL. So in this case KCL also applicable for AC and DC. Okay, AC current and DC current, or DC voltage or AC voltage. So if I take various AC source, suppose this is a V1 AC source. If I take another AC source, suppose this is V2, this is V1. So suppose V1 equals to V1m sine omega 1t, and V2 is V2m sine omega 2t. Here you see all the voltage, AC voltage source have different amplitude with different frequency. So if I take these two types of AC voltage which have different amplitude and different frequency, then it is applicable for applying KVL and KCL at this network. Yes, this is also applicable. So a AC voltage contain different AC voltage with different amplitude and different frequency. KVL and KCL can be applicable. Okay, so number 3, AC source with different amplitude and frequency, amplitude and frequency, KVL and KCL can be applicable for this network. So we have learned that a KCL and KVL is applicable for DC and AC source, and a AC source, different AC source containing different amplitude and different frequency, then KCL and KVL also applicable for that network. Okay, now if I want to study a network in frequency zone, frequency domain, for simplification to simplify the network, here all the time are voltage and current are time domain function. But in case of Laplace transformation or Fourier transformation, sometimes we have to convert the time domain function to frequency domain function with the help of Laplace transformation and Fourier transformation. So if I transform this time domain network to frequency domain network by applying Laplace and Fourier transformation, then KVL and KCL also applicable. That means, so summation of Vs must be equals to 0 at closed loop, closed path, and here also I of S must be equals to 0 for a node. Okay, so KVL and KCL also applicable at frequency domain network. That means after transform the time domain network to frequency domain network by applying Laplace and Fourier transformation, then you can also apply the KVL and KCL for that frequency domain network. Okay, so this is the main fundamental things of KCL and KVL. Theoretical part I have completed. Now there are some problem, that is 3 problem related to this topic. After this 3 problem I will solve two more problems which are harder than these three problems. So problem number 1. This is a problem. This is a 3 ohm. This is 4 ohm. This is one I1 and this is I2 and this is 5 ampere. This is 0 ampere. This is 8 ampere. So you have to calculate I1, this V and this I2. First of all, we should point out what is the node. What will be the node? This one also a node. This one also a node. This one also a node. Suppose this one number 1 node. Okay. And this one number 2 node. And number 3 node. This one is number 3 node. Okay. So we have to calculate I2, I1 and V. So using KCL and KVL, I want to calculate these 3 parameters. So first of all, I applying KVL at point 1. So applying KCL, not KVL, KCL at node 1. At node 1, this is 2 ampere current is entering. This I2 current is entering and leaving current is 8 ampere and 0 ampere. So entering current is I2 plus 2 ampere and leaving current must be equals. So leaving current is 8 ampere plus 0 ampere. So here is I2 equals to 8 minus 2 equals to 6 ampere. So one parameter I have calculated using this node. Now this is another node. Okay, this is node number 3. So using this node equation, we can also calculate what will be the current in this direction. So suppose I will take that the current through this direction is Ix. Okay, so applying KCL at node 3, we can write that the entering current is 5. Entering current is 5 and leaving current is 2 plus Ix. This is entering current. Entering current is 5 ampere and leaving current is Ix and 2 ampere. So this is Ix. So or 5 minus 2 equals to Ix. So or 3 ampere. So Ix is 3 ampere. 3 ampere. Okay, so this is 3 ampere. Now we have to calculate I1. So using the equation of KVL at node 2, so applying KCL at node 2, we can write that this is entering current, this is a entering current, this is a entering current and this is leaving current. So entering current is 2, I1 plus Ix and leaving current is 1, this is I2. I have already calculated the value of I2 and Ix. So using this value, so I1 equals to I2 minus Ix. I2 is 6 ampere. So 6 ampere minus x equals to 3 ampere, so it is 3 ampere. So I have calculated that I1 and I2. Now we have to calculate the value of V. What will be the value of V? Okay, what will be the value of V? What will be the value of V? Now we have to use the KVL equation. This is the loop. This is the one mesh or loop. This is one mesh. So here applying KVL at this loop. This is a one loop or mesh. You may call it mesh. So applying KVL at mesh, this is 1, suppose mesh 1. So current will flowing in this fashion. So this is plus minus, this is minus plus, because current flowing in this direction and current flowing in this direction. So from here I will start. So I2 into 3 plus minus, because plus minus minus plus, because current will flowing in this way. So this must be plus, this must be minus. So here will be current multiplied by the resistance, and this is minus plus, this also be minus, equals to 0. Here the process of writing KVL equation, current will flowing in this direction, so this must be plus, this must be minus. Current will flowing in this fashion, so this must be plus, this must be minus. So I start from this portion, from this point. So this is a plus voltage, this is minus voltage, this is minus voltage. So this is 1. So value of I2 is 6. So 6 multiplied by 3, this one 8, and this one will be plus V, or this 18 minus 8 equals to value of I2 is 6. Okay, so this is 10, or this is 10 equals to V. So V equals to 10 voltage. Okay, this is a 10 voltage. Today we will discuss about voltage division rule and current division rule. Here this is the two circuit. This circuit contain 3 resistance R1, R2, R3 and a DC voltage source V. These resistance are connected in series with this DC voltage source, and this circuit also contain 3 resistance and a DC voltage source, but the resistance R1, R2, R3 are connected in parallel with this DC voltage source V. The current flowing from this circuit is along this direction. Suppose this is I. From this circuit we can say that the current flowing through resistance R1 also I, current flowing through the resistance R2 also I, so current flowing through resistance R3 also I. So current through through R1, R2 and R3 are same. Okay, this current is I. Now, if I want to calculate the voltage drop across the resistance R1, we can calculate in this way. So suppose this voltage drop is V1. So V1 will be I into R1. So in similar fashion, we can say that the voltage drop across resistance R2 is I into R2 and the voltage drop across resistance R3 is I into R3. So in this circuit, the current through all the resistance are same, but voltage drop are different. V1, the value of V1, V2 and V3 are different, depend on resistance R1, R2 and R3. So in this circuit, we get current through all the resistance are same, but the voltage drop across each resistance are different, and this value will depend on the value of resistance R1, R2 and R3 because the current is same. Now, if I look this circuit, the current flowing in this way, in this direction, suppose this is I. At that point, current will divided in three parts. Suppose this is a current I1, this is a current I2 and this is a current I3. So in this case, current are different. Current through R1, R2 and R3 are different. This point and this node, this is a node and this is a node. This node, two node, all the circuit element, that means R1, R2, R3 and voltage source V, both are connected between these two nodes. Suppose this is a node A, suppose this is a node A and this is a node B. So all the circuit element are connected through these two node A and B. That's why all the circuit element R1, R2 and R3 feels the same voltage. So voltage difference between these two nodes are same, that is the V. That's why here voltage difference will be same for all the circuit element. So this resistance R1 feels the voltage difference V. So we can say that I1 equals to V by R1. Now the resistance R2 also feels the voltage difference V. So we can say that I2 equals to V by R2. Now this resistance R3 also feels the voltage difference V. So I3 will be V by R3. So in this circuit, voltage is divided in three different magnitude, and here this from this circuit here the current is divided in three different magnitude. So we can calculate V1, V2 and V3 by applying voltage division rule, and in this circuit we can easily calculate I1, I2, I3 by applying current division rule. Now we have to calculate V1, V2, V3. First of all, V1, V2 and V3. How to calculate? Suppose this is a node A and this is a node B. So the equivalent resistance between this point node A and B, between this point A and B. So equivalent resistance, this is voltage division rule, and this is current division rule. So from this circuit we can say that the equivalent resistance equals to R1 plus R2 plus R3. Okay, this is the node A and this is the node B. So if I calculate the equivalent resistance across A and B from this circuit, then it will be R1, R2 and R3. They are connected in series. So equivalent resistance will be R1 plus R2 plus R3. So this will be the resistance R equivalent. Okay, and this will be cut. So this equivalent resistance is RQ. So current I will be V by R equivalent. So it will be V divided by R1 plus R2 plus R3. So if I want to calculate V1, so V1 is I into R1. So this will be V by R equivalent into R1. So if I put this value, then it will be V by this will be I into R1. So V by R equivalent. So it will be R1 divided by R1 plus R2 plus R3 into V. Okay. In similar way, we can calculate V2 into I into R2. So it will be R2 divided by R1 plus R2 plus R3 into V. So V3 will be I into R3. So it will be R3 divided by R1 plus R2 plus R3 into V. So this is the voltage division rule. So using this formula we can calculate the voltage across each resistance. So this is the formula. Okay, this is the voltage division rule. So V1 will be V divided by R equivalent and the resistance R1. The voltage across the resistance R2 will be R2 divided by R equivalent into V. This is the voltage division rule. Now what is the current division rule? If you look this circuit, if you want to calculate value of I1, I2 and I3 in terms of I, first of all you have to calculate V in terms of I. So step one is calculate V in terms of I. So first of all, we should calculate the V in terms of I. So if I calculate the equivalent resistance between these two nodes A and B, then R1, R2 and R3 both are connected in parallel. So equivalent resistance along these two nodes A and B will be R. They are connected in parallel, so R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. So it will be 1 by R equivalent will be, this is R1, R2, R3. So it will be R2, R3. This will be R1, R3. This will be R1, R2. So R equivalent will be R1, R2, R3. If I rearranging these three terms, then we can write that R1 into R2, this. Then R2 into R3 plus R1 into R3. Okay, this is the equivalent resistance of this circuit between these two nodes A and B. Now the current I can be calculated as V by R equivalent. Okay, so it will be R equivalent means R equivalent. So this is R equivalent. So if V, you have to calculate V. So from this equation we can calculate that V equals to R equivalent into I. V equivalent into R equivalent into I. So if I put this value, R equivalent means R1, R2, R3 divided by R1, R2 plus R2, R3 plus R1, R3 into I. Okay, so this is the V. Now put this value V. So I1 equals to V by R1. So if I put this value V in this equation, then R1 will be cancel out. So it will be R2 and R3 divided by R1, R2 plus R2, R3 plus R1, R3 into I. Similarly, I2 will be V by R2. So in this case, if I put this value V, so R2 and R2 will be cancelled out. So here it will be R1 and R3. So it will be R1, R2 plus R2, R3 plus R1, R3 into I. And similarly, we can calculate I3 equals to V by R3. So it will be, so this is the R3. So from this equation, if I put this value V, so R3 will be cancelled out. So it will be R1 and R2. And this will be R1, R2 plus R2, R3 plus R1, R3 into I. Okay. So in this way, this is the formula for current division rule. This is the formula of current division rule, and this is the formula of voltage division rule. Here I have shown by giving three resistance. If you apply by two resistance, it will be easy to you. Okay, so this is, today we will discuss about delta to star transformation. Here this is a one formation of connecting impedance, that means resistance or capacitance or inductance. And this is another type of formation of connection of various resistance or capacitance or inductance. This formation looks like a delta. It also looks as a pi. That's why this formation is called delta or pi formation. And this formation looks like a star, and it also looks a Y, like a Y, or it also looks like a T. That's why this formation is called Y star, Y or T formation. Now, what is the necessity for this transformation? That means delta to star or stars to delta. Why we should need this transformation? First of all, we have to know this. We have already known that using network laws and network theorem, we can convert a very complex network into a simple network. But suppose a network may contain this type of connection of different impedance, that means resistance, it may be capacitance, it may be inductance. So depending upon our requirement, we should convert this type of formation to this type of formation so that we can calculate the circuit parameter easily. That's why we need to transformation star delta to star or star to delta. This is the main purpose of this formation. Now, how to transform this delta to star? Now, from this network, so suppose this is for delta and this is for star. Okay, so if I want to calculate the equivalent resistance between AB, so equivalent resistance between A and B node, so it will be RAB. Okay, RAB. So RAB equals to R12 parallel to R23 plus R31. If I want to calculate the equivalent resistance between these 2 points, so this resistance parallel to connection of this resistance, so this R31 and R23 are in series and they are parallel with this R12. So if I calculate this, so it will be like this. So multiplied R and divided by summation, so it will be 1 2 3 plus 1 3 1. So this is the, suppose this is equation number 1. So suppose this is equation number 1. Okay, similarly, if I want to calculate the equivalent resistance between point B and C, so it will be RBC. Similarly, we can get RBC equals to, RBC means this is parallel with this series connection in these two. So it will be R BC equals to R23 parallel to R31 plus R12. So it will be multiplied by summation. This will be summation will be 1 2 plus R23 plus R31. So suppose this is equation number 2. Then RCA will be R31 parallel to R12 plus R23. So it will be multiplied by summation. So it will be R31 into R12 plus R31 into R23 divided by R12 R23 plus R31. This is equation number 3. So from this delta connection we can calculate the equivalent resistance between AB point this, between BC point this, between CA point this. Now from star connection we can calculate that the equivalent resistance between A and B, that means RAB, can be written as RA plus RB, because this is open circuit, that's why this is equation number suppose 4. Similarly we can write that RBC equals to, BC can be written as RB plus RC. This will be 5. In that case this RA is open circuit, that's why it not concluded with this plus. So similarly we can write that RCA means RC plus RA, and in this case RB is open circuited, so this is equation 6. Now if I adding these two equation 1 2 and 3, so adding 1 2 and 3, then we get RAB plus RBC plus RCA equals to, this is R12 R23, this is R12 R23, this is R12 R31, this is R12 31. So in that case all the quantity of the upper side contain 2 times, that's why we can write that in this way, R12 plus R23 plus R31, and it will be 2 multiplied by R12 R23 plus R12 R31 plus R23 into R31. So this is the, suppose this equation is 7. Okay, this equation is 7. Now if I add this 4 equation 4 5 and 6, so if I adding 4, 5 and 6. So then we will get RAB plus RBC plus RCA equals to RA, RA, RB, RB, RC, RC. So here all the quantity are in 2 times. Okay, so this is suppose 8. This equation is 8. Now from 7 and 8, this side and this side are equal. So it must be this side and this side must be equal. So from 7 and 8 we can get that RA plus RB plus RC equals to these 2 and this 2 will be cancel out. So here it will be R12, R23, R12, R31 plus R23, this is R31, okay, divided by R12 plus R23 plus R31. So suppose this is equation number 9. Now this is RAB and this is also RAB. This is BC RBC, so this is also RBC. This is RCA and this is also RCA. If I equate this side, so from 1 and 4 we can write that RA plus RB equals to RB equals to this 12 R23 plus R12 R31, and this is R12 R23 plus R31. I have taken R12 not R1 because this node and this node and this node and this node are different. So you can differentiate these two resistance, so that to differentiate these two resistance from this node A, we have taken this resistance is R12 and this resistance is R21. If I have taken that this is R1, this is R2, this is R2 and this is R3, so it's very difficult. Okay, so in this way you can differentiate the three resistance. Okay, so this is suppose equation number 10. Similarly we can write that from equation 2 and 5 we can write that RB plus RC equals to R23 R31 R23 R12 R12 plus R23 plus R31. This is 11. Similarly RC plus RA from equation number 6 and equation number 3 we can write that R31 into R12 R31 into R23 divided by R12 plus R23 plus R31. This is 12, equation number 12. Now from equation 9, this equation, and from equation 11, so if I subtract from equation number 9 and 11. So from equation number 9 I subtract equation number 11. So from this equation, this is RB RC, this is RA RB RC. So this RB and RC will be cancel out. So it will be RA. And here is that this is R2331, 2331. This is R2312. This is 12. So here this term will be only exist. Here is this R23R31. This is R2331. So this term will be cancel out, and this is R23R12. This term will be cancel out. So here will be R12 R31 and divided by R12 plus R23 plus R31. This is equation number suppose 13. So from this equation number 13 we can get RA from these 2 points. Okay. Similarly, if I subtract 9, 12, PC and 12, 9 subtract 12, then we can get this is RA RB RC. So this is RA RC, so it will be RB. So in this case, this is R12, this is R23, this is R31. So this is R12 R31, R12 31. This will be cancel out. R31 23, 31 31 23. So this will be present. So here will be R12 R23. Similarly, if I subtract 10 from equation 9, so it will be RC. From RC it will be 1 2 and R23, 1 2 2 3. So this will be cancel out, and 1 2 3 1. This will be cancel out. So here will be R23 R31. Okay, divided by R12 plus R23 plus R31. So this is 14, this is 15. So from this three equation, we can calculate RA, RB and RC from this delta connection. Okay, so using these two formula we can easily convert this type of circuit to this type of circuit. So from delta to star connection, using this formula we can convert easily. Okay, and if you want to convert from this star connection to delta connection, you can easily calculate the formula, reverse formula, by multiplying theorem. Okay, if I have added all this equation. In that case, for transformation from star connection to delta connection, you have to multiplying theorem. Okay. Hello friends, today we will discuss about how to transform star formation to a delta formation. This is star formation and this is delta formation. So how to transform a star formation to a delta formation? In previous class we have already calculated the value of RA, RB and RC. Okay, if R12, R23 and R31 are given. So in that class we have reduced these three formula. What is the RA? RA is product of these two resistance divided by the summation of these three resistance. And what will be the RB? RB is this product of these two resistance divided by the summation of three resistance. And what will be the RC? RC is the product of these two resistance divided by summation of these three resistance. So in that class we have reduced these three formula, that means how to transform a star formation to a delta formation we have already discussed. Today we will discuss about how to transform a star formation to a delta formation. That means if RA, RB, RC is given, then how to calculate R12, R23 and R31. Now this is the three equation 13, 14 and 15. If I multiplied 13 with 14 and 14 with 15, 14 with 15 and 15 with 13, then we add it. Then what will be this value? 13 and 14. So RA, RB. This will be RA, RB. 14, 15. So it will be RB and RC. So RB and RC. And 15, 13. So RC, RA. So plus it will be RC, RA. So in that case, it will be R1, R1, so R1, R12 and here is R12. So R12 square and R21, R23 and R31. So it will be R12 square, R23 and R31 divided by R12 plus R23 plus R31. So this term and this term are same. So if I multiply these two equations, so it will be square. Similarly, if you multiplied B and C, RB and RC, so 14 and 15. So here R12 is one term, R31 is one term, but here is R23, here is R23. So R23 will be square. So here is R12 into R23 square into R31. So this term and this term are same. So it will be square value. So R12, R23, R31 square. And here if I multiply C, RC and RA, so 14 and 15 and 13. So in that case R12 is one value, R23 is one value and here is R31 is 2. So it will be square. So it will be R12, R23, R31, it will be square, and here is R12 plus R23 plus R31, it will be also a square. So this will be R12, this will be square, and here is R12 square 23 R31 plus R12 23 R31 plus R12 square. Here is RA, RB plus RB, RC plus RC, RA. Okay. Then RA, RB plus RB, RC, RC, RA. This will be same. So here is R12, R23, R31. This will be plus. Okay. So here is R12 plus R23 plus R31. This is square value. So this is R12, R23, R31. Here is R12, R23 and R31. So in that three terms both have the same quantity R12, R23 and R31. That's why this term can be taken as a common term. Okay, this can be taken as a common term. Here it will be R12, here it will be R23 and here it will be R31. This is the same value, so this square will be cancelled. So it will be R12, R23, R31 and here will be R12 plus R23 plus R31. So this equation suppose 16. Okay, 16. Now we have to calculate what will be the value of R12. So here is 1 2, that means R23 and 31. So this term can be taken as a RC. This is R23, R31 and this is the value of it can be written as RC. Okay, so from equation 16 and this 15, using equation 16 and 15 we can write that RA RB plus RB RC plus RC RA equals to R12 into RC, because this value is RC. So from this equation we can write that R12 is this. Divided by RC. So this is equation 17. Similarly, if I want to calculate R23, then this value, so if I taken this value, what will be this value? R12 and this is R23. Okay, R23 means R12 and 31. So R12 and 31 are, this is divided by this function. So it can be written as RA. It can be written as RA. So similarly, from equation 16 and 13 we can write that R23 can be written as RA RB plus RB RC plus RC RA divided by RA. This is RA. So this is equation 18. And if I take, this is the equation 18, that means R23. If I want to calculate R31, so what will be this value? This value R12, R23, R12, R23, and this is will be RB. So it will be RB. So similarly, from equation 16 and 14, So from equation 16 and 14 we can write that R31 equals to RA RB plus RB RC plus RC RA divided by RB. So this is equation 19. So through these three equation number 17, equation number 18 and equation number 19, using these three equations we can easily calculate what will be the R12, R23 and R31 from the given RA, RB and RC. What will be the R12? What will be the R12? This is the two junction 1 and 2. So this is RC. So product of these three value RA, RB, RC, product formation divided by RC. This is RC. What will be the R? This is R23. This is the junction 2, 3. So this divided by this resistance. What will be this? This resistance RE, and this is the product form. Okay. And if you want to calculate R31, so this is the R31. This resistance R open junction. So it will be divided by RB. So using this formula, we can easily calculate or easily transform one formation to another formation. In previous class we have already discussed how to transform delta to star. In this class I have already discussed this, that how to calculate these three resistance from these three resistance. So how to transform a star formation to a delta formation. In the next class we will discuss some problem related to this star to delta or delta to star formation. Hello friends, today we will discuss about Thevenin theorem. Suppose this is a network. This network has two terminals. So number one, it has two terminals. Okay. Number two, it must be a linear network. It must be a linear network. Number three, it must be a bilateral network. So suppose this is a two terminal linear bilateral network. So it may contain several number of passive and active circuit element. That's why it looks very complex. So it is not easy to calculate current, voltage and power in a particular circuit element in this network. So we should or we have to convert it into a simple network so that we can calculate the circuit parameter like current, voltage and power in a particular circuit element in this network. By using Thevenin theorem, we can convert it into a simple network so that we can calculate the circuit parameter easily. So by using Thevenin theorems, we can convert it into a simple circuit. This circuit contains a voltage source. This voltage source is called Thevenin voltage source, and this voltage has a series impedance. Suppose this is a series impedance. This series impedance called thevenin impedance, and this is the two terminal AB open circuit terminal. So according to Thevenin's theorem, a two terminal linear bilateral network containing several number of active and passive elements can be converted into a simple network having one voltage source with in series impedance ZTH. What is the VTH? VTH is the voltage across the open circuit terminal. Okay, so VTH is the voltage across the open circuit terminal. And what is the ZTH? ZTH is the impedance, equivalent impedance of this network. So it is a equivalent impedance. Seen across these two open circuit terminal. Seen across the open circuited terminal. By replacing number one, this network may contain independent voltage source, independent current source, or it may have dependent voltage source and dependent current source. So ZTH is the equivalent impedance seen across this open circuit terminal. By replacing number one, if this circuit contain independent voltage source, so replacing independent voltage source with their internal resistance or impedance, internal impedance. Number two, it may have independent current source. So independent current source must be kept at open circuited. Okay. Number three. So I have discussed 2 points. One is independent voltage source. Number two is independent current source. If this network may contain dependent current source or dependent voltage source. So what happens if this network contain dependent voltage source or dependent current source? Both the energy source, that means dependent energy source must be kept as it is. Okay, so all the dependent current source or dependent voltage source must be kept as it is. So this is the main fundamental things of the Thevenin theorem. So what is the statement of this Thevenin theorem? Any two-terminal linear bilateral network containing active or passive element can be converted into a simple network containing a voltage source series with a impedance where the voltage is the voltage across the open circuited terminal and the series impedance is the equivalent impedance seen across this open circuited terminal by replacing all the independent voltage source with their internal resistance or impedance, and independent current source must be kept at open circuited, and all the dependent energy source, that means dependent voltage source or dependent current source, must be kept as it is. So do not change the position of dependent energy source, that means dependent current source or dependent voltage source. Okay, so this is the main things of Thevenin theorem. Now, how to apply this Thevenin theorem to calculate the circuit parameter like current, voltage and power in a particular network. So what is the application of this Thevenin theorem? So using Thevenin theorem, you can calculate current, voltage, power in a particular circuit element in this network. Okay, so using Thevenin theorem, we can calculate the current, voltage and power in a particular circuit element in this network. So to do this calculation, you should calculate ZTH and VTH. So how to calculate Thevenin voltage and Thevenin impedance, I will describe later. Now, what is the application? Now, if this network may contain DC energy source, AC energy source. So where this theorem is applicable in AC source or DC source, so Thevenin theorem is applicable. Thevenin theorem is applicable number one, if this network contain only DC source. So you can apply the Thevenin voltage. Number two, if this network contain AC source, energy source, in that case you can apply this Thevenin theorem. Number three, if this network contain both AC and DC, in that case you will able to apply this Thevenin theorem. So in this case, now second things in terms of energy source, this network may contain dependent energy source and independent energy source. So dependent upon the property of this energy source of this network, the process of calculation of VTH and ZTH will be different. So how to calculate this VTH and ZTH will depend on the property of the network having the energy source. Okay, so the procedure of calculation of VTH and ZTH. Okay, so number one, if this network containing only independent energy source, in that case VTH will be the VOC. That means this VTH will be equals to this open circuited voltage. Okay, now, and number two is if the network contain only independent and dependent source, then how to calculate this? Number two, network containing dependent and independent energy source. In this case VTH equals to VOC, that means the open circuit voltage, but ZTH equals to the VOC divided by ISC, that means short circuited current through this open circuited terminal. So if this network contain only independent energy source, in that case VTH equals to VOC, and ZTH is the equivalent resistance seen across this terminal by replacing all the voltage source with their internal impedance, and the current source are kept in open circuited. Now if the network contain dependent and independent energy source, so both dependent and independent, in this case the VTH will be the open circuit terminal voltage, but ZTH must be VOC divided by ISC. What is the ISC? ISC is the short circuited current. If you short this open circuit terminal, so there will be a short circuited current through this short circuited terminal. So this is the short circuited current through this open circuit terminal. So in this case you will able to calculate ZTH in this way. Number three, if this network contain only dependent source, only dependent energy source, so in this case VTH must be 0. So if this network contain only dependent energy source, in that case VTH must be 0, but you can calculate ZTH. Okay, so there will be some equivalent Thevenin impedance, but the Thevenin voltage will be 0. Now what is the limitation of this Thevenin theorem? What is the limitation of this Thevenin theorem? What is the limitation? Number one, so limitation of this network. theory, Thevenin theorem. Okay, so limitation is a network is linear in a certain range of this network parameter. So this theorem is valid for linear region of this network. It does not valid on non-linear region of this network. So number one is it is valid on linear region of this network. Number two, we have calculated this circuit from this network. So if I calculate the power of this equivalent circuit and I calculate the power of the real circuit. So power of this real system and power of this Thevenin circuit may not identical. Okay, so both these case are may not identical. So in terms of power, so number one is this network valid only within the linear region of this network. Number two, if I calculate the power of the original network and if I calculate the power of this Thevenin circuit, then these two may not be identical. Okay. Number three. What is the number three? This network has a IV characteristics, that means IV diagram, and this original circuit have a IV characteristics. So in this case, the IV characteristics is drawn in this the IV characteristics of this equivalent circuit is drawn only the point of load resistance. Okay, so if I connect the load at this point, so IV characteristics of this network is drawn in the viewpoint of the load resistance. Okay, so this is the three limitation of this Thevenin theorem. In the next class, I will solve how to calculate ZTH and VTH with several number of problem. Friends, today we will discuss about the application of Thevenin theorem. That means how to calculate the Thevenin voltage and Thevenin impedance. In previous class, I have already discussed that there are three cases for calculation of Thevenin voltage, Thevenin impedance. Number one, when the circuit contain only independent energy source. Number two, when the circuit contain both independent and dependent energy source. Number three, when the circuit contain only dependent energy source. Okay, this is the three cases. Today I will discuss the number one case, when the circuit containing only independent energy source. So in this case, the VTH will be the open circuit voltage. Suppose this is one example, this is AB. So this AB is open circuit terminal. So the voltage across open circuit terminal will be the VTH. Number two, that means ZTH. What will be the ZTH? ZTH will be the equivalent impedance of the circuit seen across this open circuited terminal by replacing all the voltage source with their internal impedance, and all the current source are in open circuited. Okay, so problem number one, this is the problem. Okay, so you have to calculate the VTH and ZTH, that means RTH. Now if you want to calculate VTH, you have to calculate the open circuited voltage, that means voltage across this terminal. So to calculate voltage across this terminal, you have to calculate the node voltage VA and node voltage VB. If you are able to calculate the node voltage VA and node voltage VB, then you can easily calculate the open circuited voltage across AB. Now how to calculate this VA and VB? Suppose this is X and this is Y, and this is X dash and this is Y dash. These 2 points X and X dash are identical and Y and Y dash are identical, same point. I have taken this different point to differentiate these two branch. Okay, so this X Y branch contain 100 ohms, 60 plus 40, 100 ohms. This branch also contain 40 plus 60, 100 ohms. Okay, so if I look at this from this point, the equivalent, suppose this point are P and Q, this point is PQ. So if I look this circuit from this region, then the equivalent resistance are equivalent from this PQ portion. Okay, PQ, it will be 100 parallel 100. So it will be 100 multiplied by 100 divided by 100 plus 100. So it will be 100 multiplied by 100 by 200. So it will be 50 ohms. 50 ohms. So if the current through this from this voltage source is I, then I will be 100 volt divided by 100 volt divided by 50 ohms. So it will be 2 ampere. Now this branch contains same resistance and this two branch contains same resistance. That's why the current through this branch and this branch will divided by equal divided. So if this is 2 ampere, so it will be 1 ampere and this is will be 1 ampere. Okay, so suppose this is I1, so current is 1 ampere, this is 1 ampere. So current through X Y branch is 1 ampere and X dash also 1 ampere. So current through X dash Y dash branch is also 1 ampere. Okay, now if I take this mesh, suppose this is a mesh. Okay, if I take this mesh, then the voltage will drop across this resistance 60 ohm. The voltage drop across 60 ohm resistance equals to 60 multiplied by 1 equals to 60 volt. So voltage drop across this is 60 volt, this is 100 volt. So from this mesh you can calculate that VA equals to 100 minus 60 volt, that means 40 volt. If you calculate similarly the voltage across this branch 40 ohms, the current flow through this, so this will be current through 40 ohms, then the voltage across this 40 ohm resistance will be 40 volt. So similarly VB will be 100 minus 40, that means 60 volt. Okay, so in this way we can calculate the node voltage VA and VB. Now the open circuit voltage VOC, so open circuit voltage VOC equals to VBA, that means VB minus VA, so it will be 60 minus 40 equals to 20 volt. This 20 volt will be VTH. So I have calculated the VTH, that means Thevenin voltage will be 20 volt. Okay, now how to calculate the Thevenin impedance? To calculate Thevenin impedance, you have to replace this voltage source with their internal impedance. So this voltage source has 0 internal impedance, so it will be like this. So this voltage source is short circuited. Okay, because the voltage source has 0 internal impedance, that's why we short circuited this voltage source. So to calculate the equivalent Thevenin equivalent impedance. So if you short circuited this junction, then this can be rearranged as this point, this point, this point, this point are all same. So suppose this is a point and this is a B point, and here these are short circuited, that's why x dash y dash are same point. So from point A there is a resistance 60 ohms, so this is suppose 60 ohms. Okay, from A there is a 40 ohms, so this is 40 ohms. 40 ohms. Similarly, from B there is a 40 and there is a 60, so this is 40 ohm and this is 60 ohms. From this picture we can write that this is A, this is B. So the equivalent resistance of this portion will be 60 parallel 60 multiplied by 40 divided by 60 plus 40. So it will be 60 multiplied by 40 divided by 100. So this cancel, so it will be 24. So from this portion it will be 40 ohms. So from A to B, so this is series connection, so it will be 48 ohms. So RTH equals to 48 ohms. Okay, so first problem is completed now. So in this way you can calculate the Thevenin voltage and Thevenin impedance. Now look this problem number 2. This is problem number 2. So problem number 2 contain 2 voltage source. Okay, 2 voltage source. Suppose the current is I. Suppose I have taken this current is I in this way. This is current I. So if I take this mesh, this is mesh number 1. Mesh number 1. If I take this mesh and applying KVL, okay, so applying KVL at mesh 1. This is mesh 1. So current flowing through this direction, though this is plus minus, this is plus minus, this is plus minus minus plus. So using KVL we can write that 4 into I plus 5, because plus minus plus minus. Okay, so this will be 5 plus minus, that means 6I minus plus, that's why this is 10 equals to 0. Plus minus minus plus. So current flowing through this I. This is I. So from this equation we can write that 10I equals to 5. Okay, this is 10, this is 5, so it will be 5. So I is 5 by 10 equals to half ampere. Okay, half ampere. So current through this direction I equals to half ampere. So you have to calculate the open circuit voltage. So VTH, open circuit voltage, that means open circuited voltage, that means VAB equals to AB from this point. This is plus minus, this is minus plus, because current is flowing through this direction. Okay, so current through resistance 6 ohm is along this direction. So voltage drop across the 6 ohm resistance is minus plus. Okay, so it will be 6 plus half. This direction is a minus, this will be plus, so it will be 3 volt. So open circuit voltage AB equals to 10 minus 6 multiplied by half VI into R. So this is this volt. So it will be 7 minus 3 volt equals to 7 volt. So this 7 volt equals to VTH. So open circuit voltage across the terminal AB equals to the VTH. So VTH is 7 volt. How to calculate this? This is positive. Current through this 6 ohm resistance along this direction. So voltage drop is along this direction is positive. So along this direction voltage is negative. That's why plus minus minus plus we have taken is this is plus and this portion is minus. That's why it is 7 volt. Now how to calculate the equivalent resistance seen across this open circuit terminal? So this circuit can be redrawn as this is voltage source and this is resistance. Okay, this is resistance 6 ohm and this is resistance and this is another voltage source. This voltage source have 0 internal resistance, that's why it is short circuited. This is short circuited. This is 4 ohms. So equivalent resistance are equivalent equals to the 6 parallel 4. So it will be 6 4 divided by 6 plus 4. So it will be 24 divided by 10. So it will be 2.4 ohms. So 2.4 ohm is equals to RTH. So in this way you can calculate the equivalent Thevenin equivalent impedance and Thevenin voltage. In next class I will discuss the problem with independent current source. These two circuits contain only independent energy source. So the circuit containing only independent energy source, so in this case VTH equals to the VOC. So VTH will be the open circuit voltage across the open circuited terminal, and the RTH or ZTH will be the open circuit equivalent resistance seen across the open circuited terminal by replacing all the voltage source with their internal impedance, and all the current source are kept open. Okay. So now number 3 problem. So number 3 problem. So if you are able to calculate the open circuit voltage of this open circuit terminal, that will be the VTH. So if this open circuit voltage VOC equals to the VTH according to this rule, because this circuit contains independent energy source. Now if I take this node X and this is a node voltage Vx, and this 80 ohm resistance is connected to a open circuited terminal. Since these 80 ohm resistance are connected to open circuited terminals, that's why the current through this resistance is 0. So I80, so this is 80, so current through the 80 ohm resistance is 0, because or since this 80 ohm resistance is connected to open circuit terminal, open circuited terminals. That's why the current through this 80 ohm resistance is 0. Number 2, the voltage drop across this 80 ohm resistance must be equals to the 0. So V across the 80 ohm resistance must be 0, because I80 equals to 0. So there is no voltage drop across this 80 ohm resistance. So this node voltage VA must be equals to the Vx. So the node voltage Vx must be equals to the node voltage at VA. So node voltage at VA must be equals to the VTH. So this is the VTH, that means node voltage is VTH. That's why the Vx must be equals to VTH. Okay. Since the voltage drop, since the voltage drop across this 80 ohm resistance is equals to 0. Now if I apply, so applying KCL at node X, this is the node X. So if I apply the KCL at node X, current through this branch is along this direction. So current through this branch will be along this direction. So this current through 20 ohm resistance will be VTH minus 60 divided by 20. This is VTH minus 60 divided by 20. So current through this branch is this, and the entering node current is 20 ampere, 2 ampere, so it will be 2. So from this equation we can easily calculate that VTH equals to 40 plus 60, that means 100 volt. So VTH is 100 volt. Okay, so now you have to calculate the RTH. What is the RTH? RTH is the equivalent resistance seen across this terminal by replacing the voltage source with their internal impedance, and current source are kept open. So if I arrange this circuit, so it will be look like this. So this is A, this is B. So this is 80 ohms, 80 ohms, and this is 40 ohms, 40 ohms, and this is a current source, and this is another 20 ohms, and this is a voltage source. So voltage source, the voltage source will be replaced by their internal impedance. Since this voltage source has zero internal impedance, that's why it is short circuited. Okay, and current source are open circuited. Okay, OC, open circuited. So you have to calculate the R equivalent from this point AB must be equals to the RTH. So R equivalent equals to RTH equals to 80. This resistance are in series, so 80 plus 20, and this resistance is not included in calculation of this RTH because this is open circuited terminal, so there is no current flow through this resistance 40 ohms. That's why this resistance is not included in this case. So it will be 100 ohms. So RTH is 100 ohms. So this is the problem number 3. In previous class I have solved 2 problems. Okay, and there is another 2 problem. Now problem number 4. Problem number 4, you have to calculate the open circuit voltage across this terminal. That will be the VTH. So if you want to calculate the open circuit voltage across this terminal AB, and that will be the VTH, so in this case you have to calculate this current through this branch, that means 6 ohm. If you are able to calculate current through this 6 ohm resistance, then you will be able to calculate VOC equals to the current through this branch multiplied by 6. So first of all you have to calculate the current through this branch. So suppose this is current from this voltage source is I1. So this current will divided in 2 paths. Suppose this along this direction I2, so this will be I2 and this will be I2. So current through this branch, it will be I1 minus I2. So current through this 2 ohm resistance, it will be I1. Okay, so if I take, this is a one mesh, this is mesh number 1, and if I take, this is another mesh, this is mesh number 2. Now our aim is to calculate this I2. So applying KVL at mesh 1, this mesh. So if I start from this point, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus, this is minus, this is plus. So from this point, from this, it will be 2 multiplied by I1, this is plus minus, this is plus minus, plus I1 minus I2 multiplied by 6, I1 minus I2 multiplied by 6, and this is 2 multiplied by I1 minus 12 equals to 0. So plus minus, this will be I1 into 2, this is plus minus I1 minus I2 into 6, and this is plus minus I1 into 2, and this is minus plus, that's why minus 12. So from this equation you can calculate that this is 2, this is 2, so this will be 4 and this is 6, so this is 10 I1 and it will be 6 I2 minus 6 I2 equals to 12. Okay, this is 6, 10 I1 plus 6 I2 equals to 12. So this is the equation number 1. Now similarly applying KVL at mesh number 2. This is mesh number 2. So if I start from this point, plus minus, this is plus minus, this is minus plus. So this is I2. So I2 multiplied by 2, this, and this I2 multiplied by 6 plus this is I2 multiplied by 2, and this is minus, this is plus, so it will be minus I1 I2 into 6 equals to 0. So from this point you can calculate that this is only I1, so this is minus 6 I1, this is 2, 6, 8, 10, and this is plus 6, so it will be plus 16 I2 equals to 0. This is equation number 2. So from these two equations you have to solve the value of I2. So if I multiply this equation by 3 and this is multiplied by 5, then I will get this is 30 I1 and this is minus 18 I2 and this is will be 36 18 and this is 30. Now from this equation if I multiply by 5, so it will be minus 30 I1 and this is plus this is I2 equals to 0. So here this will be cancelled out, so here it will be 2 and this will be 62 I2 equals to 36. So I2 will be 36 divided by 62, so it will be 18 divided by 31. This is ampere. Okay, so current through this 6 ohm resistance is 18 by 31. Now how to calculate the VTH? So VTH equals to the VOC, open circuit voltage. So voltage across this 6 ohm resistance, so it will be I2 multiplied by 6, I2 multiplied by 6. Here is I2 is 18 divided by 31 multiplied by 6, so it will be 108 divided by 30 volt. Okay, so VTH is this. So in this way you can easily calculate the VTH of this circuit. Now you have to calculate the RTH. So how to calculate RTH? The equivalent resistance seen across this terminal by replacing the voltage source with their internal impedance. So this circuit can be arranged in this way. So this is A, this is B, this is 2, this is 2, and this is voltage source. This is 2, this is 2, okay, and this is 6, and this is 6. So this is 6 ohm, this is 6 ohm, this is 2 ohm, this is 2 ohm, and this is also 2 ohm, this is 2 ohm, and this is voltage source. So voltage source is to be short circuited. Okay, so the RTH will be the equivalent resistance seen across this terminal. So what will be this equivalent resistance from these 2 points? So R equivalent equals to the 6 parallel to this 2 plus 2, 2 plus 2. From this point, if I look this circuit from this point, so this equivalent resistance seen across this point, it will be 6 parallel to 2 plus 2. This because this is are in series, so it will be 6 multiplied by 4, so it will be 2.4. Now RTH will be 6 parallel to 2 plus this equivalent 2.4 plus 2. This resistance parallel to 2 plus 2.4 plus 2. So in this case it will be 6 multiplied by 6.4 plus 6 plus 6.4. So it will be 6 multiplied by 6.4 divided by 12.4. So if you, this is 3, this is 6, this point is 6, 2, okay, 6, 2. So it will be 3, 1, this is with 3, 2. So it will be 696 divided by 30 ohms. Okay, so this is the RTH. So in this way you can calculate the VTH and RTH of a circuit. In the next class today we will discuss about this problem. This problem contains one independent current source and one dependent voltage source. So when the circuit contains both dependent and independent energy source, then there is a rule to calculate VTH and ZTH. So in this case, so VTH will be equals to the open circuit voltage across the open circuit terminal. So this is VOC must be equals to the VTH, okay, across the open circuit terminal. Now you have to calculate the ZTH or the RTH. So RTH will be the open circuit voltage across this terminal divided by the short circuited current through this open circuited terminal. So if I short this two terminal AB, then the current through this terminal is ISC. So what is the ISC? Short circuited current. So it is a short circuited current through the given terminal. So if I short these two terminal A and B, there is a short circuited current. This short circuit current is the current through this A and B when these 2 points are short circuited. Okay, so this is the rule. When the circuit contain both independent and dependent energy source. In previous class I have already discussed that when the circuit contain only independent energy source, there is another rule to calculate VTH and ZTH. So this is the rule. Now I will discuss this problem number 1. So if the open circuit voltage is VTH, so the node voltage at node A, this is node A, so node voltage at node A, that means VA must be equals to VOC equals to VTH. So this is the node voltage A, this node voltage is VTH. Okay, because the open circuit voltage equals to the VTH. Now if I apply the node voltage at node A, what will happen? So applying KCL at node A, this is the node, so all the nodes are A, so this is a node. So current through this junction will be VTH minus 4I divided by 2, current through this junction. Now current through this junction is plus VTH divided by 2, current through this junction. Now current through this 4 ohm resistance is equals to VTH divided by 4 must be equals to the incoming current towards this node. So from this node, this is a node, so all the points are A, so current will pass through this resistance 2 ampere along this direction, so it will be VTH minus 4I divided by 2. Now current through this 2 ohm resistance equals to VTH minus 0 divided by 2, that means VTH by 2. Now current through this 4 ampere resistance is VTH by 4 and current entering current to the node is 4, so that's why it will be 4. Okay, this is 4 ampere, so it will be 4. Okay, now from this equation we can write that, so this will be 4, so it is 2 VTH minus 8I plus 2 VTH plus VTH equals to 4. So from this equation, this is 2, this is 2, 4, this is 5 VTH. Okay, so this is 5 VTH minus this is 8I equals to 8. So this is equation number 1. So applying KCL at node A, I have reduced this formula 5 VTH minus 8I equals to 8. This is the equation number 1. So this is 4 and this is 4, so it will be 16, not 8. Okay, it will be 16. This is equation number 1. Now this is I. So if I look this branch, this is current I and this is 2 and this is node voltage VTH. So this is node voltage VTH and this is 0, and this is current, and this is resistance. So using Ohm's law, we can write that I equals to VTH divided by 2, where from this portion, so from this portion we can write that I equals to VTH by 2, VTH divided by 2 equals to I. Okay, so if I put this value in this equation A1, then we will get 5 VTH minus 8 multiplied by VTH divided by 2 equals to 16. So it will be 5 VTH minus this is 4 VTH equals to 16. So it will be VTH equals to 16 volt. 16 volt. So in this way you can calculate the VTH of this circuit. Thevenin voltage is 16 volt. Now you have to calculate the ZTH or RTH. To calculate RTH, you have to calculate short circuited current. So RTH equals to VOC divided by ISC equals to VTH divided by ISC, because VTH equals to the open circuited voltage. Now what will be this ISC current? So if I short this, if I short this two terminal, if I short this terminal, short circuited A and B, so current through this short circuited terminal will be 4. This is the 4 ampere. So short circuited current through this given terminal will be 4 ampere. This is 4 ampere. From this circuit you can write this 4 ampere, because this is 4 ampere and this is dependent current source, voltage source. That's why the current through this short circuited terminal, given terminal AB, is equals to the 4 ampere. Okay, so for this case RTH equals to VTH, that means 16 divided by 4, so equals to 4 ohm. So RTH equals to 4 ohms and VTH is 16 volt. So in this way you can calculate the VTH and ZTH of a circuit containing both independent and. Today we will discuss about this problem. This problem contains only one dependent energy source. So how to calculate the Thevenin voltage and Thevenin impedance of this circuit? In previous class I have already discussed how to calculate the Thevenin voltage and Thevenin impedance of a circuit consisting independent energy source. Number 2, consisting both dependent and independent energy source. Now this circuit contain only dependent energy source. So in this circuit, how to calculate VTH and ZTH? So if a circuit consisting dependent energy source, the VTH will be 0. How VTH is become 0, I will discuss using this problem later. Number 2, how to calculate ZTH or RTH? To calculate RTH, you have to insert or connect 1 volt DC source across this open circuit terminal. Okay, so using this problem I will calculate VTH and ZTH. So let's start. So this is the problem. So this 1 ohm resistance is open circuited. So current through this open circuited terminal is 0. So the current through this resistance 1 ohm is 0. That means Ix equals to 0, because since 1 ohm resistance is connected to open circuit terminal, circuited terminal. So this 1 ohm resistance is connected to this open circuit terminal A. That's why current through this resistance 1 ohm is 0. If Ix is 0, then this dependent voltage source will be off. So dependent voltage source will be off, because Ix is 0. So this will be 0. So voltage alpha Ix must be 0. That means this is off condition. So this circuit does not contain any active source. Okay, if Ix is 0, that means this is off. So if this is off, there is no voltage source, active voltage source in this circuit. That's why VTH equals to 0. Since the circuit does not contain any active energy source, because this source become dead because of the Ix is 0. So why the Thevenin voltage of a circuit consisting dependent voltage source or dependent energy source is 0, this is the explanation. Okay, so this is the way how to calculate the VTH of this circuit. Now you have to calculate the RTH or ZTH. So to calculate RTH or ZTH, you have to connect 1 volt DC source. You have to connect 1 volt DC source across this open circuit terminal. Okay, open circuit terminal. Now this is a node. Suppose this node is X. This node is X. So this node voltage suppose X. This node voltage suppose X. Now applying KCL at node X. So current through this branch will be Vx minus alpha x divided by 1. So Vx minus alpha Ix divided by 1 plus current through this 2 ohm resistance is equals to Vx divided by 2 plus current through this 1 ohm resistance is Vx minus 1 divided by 1 must be equals to 0. this is 1 volt. So Vx minus 1, the node voltage of node A is 1 volt. So Vx minus 1 divided by 1. Okay. So this is the KCL at node KCL equation of node X. So this is equation number 1. Now if I take this branch, that means X A branch. So from X A branch we can write that this is direction of the current Ix is along this direction. So this voltage is greater. So 1 minus Vx divided by 1 is equals to Ix. So current through this junction is along this direction. Okay, so this node voltage is 1 volt and this node voltage is Vx. So 1 minus Vx divided by 1 equals to Ix. So Ix is or 1 minus Vx equals to Ix, or Vx is equals to 1 minus Ix. This is the equation number 2. So Vx equals to 1 minus Ix. Now if I put the value of Vx from equation 2 into this equation 1, then I will get, this is Vx, so Vx is 1 minus Ix, so this equation will be 1 minus Ix minus alpha Ix divided by 1. Okay, so this term become this. So Vx equals to 1 minus Ix minus alpha x divided by 1. Now plus this is Vx equal to 1 minus Ix, so 1 minus Ix by 2, and this is Vx, so Vx is 1 minus Ix, so plus 1 minus Ix minus 1 by 1 equals to 0. This is the equation. Okay, so from this equation we can write that, or this is 2, so it will be 2 minus 2Ix minus 2 alpha Ix plus 1 minus Ix plus 2 minus 2Ix minus 2 equals to 0. So now 0. So now Ix is, this is Ix, this is Ix, this is Ix, this is Ix. So this is minus 2, minus 2, minus 4, this is minus 1, so minus 5Ix. So minus 5Ix. And this is minus 2 alpha Ix. This is 2, this is 1, 3, this is 5 minus 2, that means 3, plus 3 equals to 0. This is the equation. So minus 5Ix minus 2Ix equals to 3. Now if this is minus, if I take minus Ix common, so this is, if I take Ix is common, so minus Ix is common, then it will be 5 plus 2 alpha is equals to minus 3. So this minus will cancel, so it will be, or Ix equals to 3 divided by 5 plus 2 alpha. So this is the Ix. This is equation number 3. So Ix is 3 divided by 5 plus 2 alpha. Now you have to calculate RTH. What is the RTH? This is the Ix and this is the VTH is 0. Now you have to calculate RTH. Now RTH equals to, this is the Ix, so voltage RTH equals to V equals to IR, so IR equals to V by I, so this is V by I. So the V is 1 volt. I have employed this 1 volt DC source, so this is 1 volt, and this is Ix of the circuit is Ix, so this is Ix is 3 divided by 5 plus 2 alpha, so it will be 5 plus 2 alpha divided by 3. So it is the Thevenin impedance of this circuit. So if I want to calculate the RTH of a circuit, of this circuit, I have to calculate this Ix. So this Ix is from this voltage source 1 volt. So the equivalent voltage across these two terminals will be this voltage divided by this current. So this voltage is 1 volt and this current I have already calculated for this circuit is 3 divided by 5 plus 2 alpha. That's why the RTH equals to 5 plus 2 alpha by 3. So in this way you can calculate the RTH and VTH of this circuit consisting only dependent in as 2 terminals. So this is a 2 terminal network. It must be a linear network. It should be also a bilateral network. And this network may contain several number of passive element and active element. Passive element means resistor, capacitor and inductor, and active element means various energy source, that means current source and voltage source. It may be dependent energy source or independent energy source. So this network looks very complex, so it is very difficult to calculate the current, voltage or power in specific circuit element. That's why we should transfer it into a simple network by using Norton theorem. So according to Norton theorem, this network can be replaced by a current source. In parallel to a equivalent impedance Rn. This is the terminal A and B, where IN equals to the equivalent current source, it can be written as short circuited current through given terminal. And what is the Rn? Rn is the equivalent impedance or resistance seen across this given terminal. Seen across the given terminal. By replacing all the voltage source with their internal impedance and all the current source are kept as open. This is the Rn and In. So what is the statement of Norton theorem? Any two terminal linear bilateral network containing several number of active or passive elements can be replaced by an equivalent current source in parallel to an equivalent impedance or resistance, where the equivalent current source is the current short circuited current through the given terminal, and the equivalent resistance is equals to the equivalent resistance seen across the given terminal by replacing all the independent voltage source with their internal resistance, and independent current source are kept as open. So this is the Norton's theorem. Now, what is the limitation of this Norton theorem? Here you see that this theorem only valid for linear network. So if the circuit contain nonlinear element, then you cannot apply Norton theorem. And this Norton theorem can be valid as AC source, DC source, and it can be applied in time domain as well as frequency domain. Now I will solve this problem. This problem contains one independent voltage source and this one dependent voltage source. Okay, so how to calculate the Norton equivalent Norton current source and the Norton equivalent resistance in this circuit? So this is a voltage source, this is dependent voltage source, and this is load resistance. So this circuit contains dependent and independent energy source. So how to calculate this problem? So number one, you have to calculate the ISC, that means IN equals to ISC, short circuited current to the given terminal. So this is the terminal, this is the terminal. So this terminal can be, you have to short circuit it. So this is the current, short circuited current. This is the short circuited current. You have to calculate this short circuited current because IN equals to ISC. So how to calculate? Suppose this is a mesh 1. So this current, suppose this current is I1. So this is mesh 1. And this mesh is 2. This is mesh 2. And this current is suppose I2. So if I apply the KVL, so from this branch we can write that I equals to I1 minus I2. So this is equation number 1. So this is the 2I and this is I. So I have taken I1 in this direction and I2 in this direction. So this small I can be written as I1 minus I2. This is the equation number 1. Now applying KVL at node at mesh 1. This is the direction. So this is plus minus minus plus. So I1 into 4 minus 2I. This is plus minus. So this is plus 3 into I1 minus I2 minus 10 equals to 0. So if I put this value I1 and I2 instead of I, so what will be the equation? This is 4I1 and this will be can be written as I1 minus I2. This is 3 multiplied by I1 minus I2 equals to 10. So this is 4I1, this is minus 2I1 and this is 3I1. So next step it will be 4, 2 and 3. So it will be 5I1. This is plus I2, this is minus I2. So it can be written as minus I2 equals to 10. This is equation number 2. This is equation number 2. Now if you apply the KVL at mesh 2, so applying KVL at mesh 2, what will be the equation? Suppose this is plus minus, so 6I2 and this, if you taken, this is plus minus, so the current, this is plus minus, so minus plus, so it can be written as minus. Okay, so current through this is I1 minus I2 equals to 0. So if you taken current, direction of current in this way, so this is plus minus minus plus, so the current through this direction is I1 minus I2. So in this way it can be written as 6 this is also a 3, so it is 3. Okay, so 3 into I1 minus I2, so it will be I6I2 minus 3I1 plus 3I2 equals to 0. So it will be 3, this is 9I2 equals to 3I1. So this is 3I2 equals to I1. So this is equation number 3. Okay, so if you solve these two equations 2 and 3, so from equation 2 and 3, we can write that 5 into I1 means 3I2. So this is 3I2 minus I2 equals to 10. So from this equation we can write that this is 15I2 minus I2 equals to 10. So it can be written as 14I2 equals to 10, or I2 equals to 10 by 14. So if you divided this function 10 by 14, so it will be 0.714 ampere suppose. So this is the I2. So I2 equals to ISC. So I2 equals to ISC. ISC means the IN. So IN equals to 0.714 ampere. This is the IN. Now you have to calculate the RN, that means equivalent impedance. So how to calculate equivalent impedance? This is the rule for calculation of IN. So how to calculate RN? RN can be calculated as VOC divided by ISC. So you have to calculate the open circuit voltage, that means thevenin voltage divided by ISC. So from this circuit we have to calculate the open circuit voltage across this terminal and or VTH across this terminal. You cannot calculate the equivalent resistance seen across this terminal because this is a dependent energy source. If the circuit contains dependent energy source, then you cannot calculate the equivalent resistance by seeing across this terminal. So to calculate this RN, you have to calculate the open circuit voltage across the open circuit terminal. This is the open circuit. So if you want to calculate the open circuit voltage VOC, you have to calculate this I. If you are able to calculate this I, then this is the 3 ohms, this is the 4 ohms, this is 10, this is 2I. So if I take the current in this direction, then using KVL we can easily calculate this I. So if we are able to calculate I, then I into 3, it will be the open circuit voltage across this terminal. So applying KVL at this mesh, we can write that 4I, this is plus minus, this is minus plus. So 4I minus 2I plus 3I minus 10 equals to 0. So it is 5I equals to 10. This is 5I equals to 10. So I equals to 10 by 5. So it is 2 ampere. It is 2 ampere. Then VOC, that means Thevenin, it will be 3 multiplied by I. So 3 into 2, it will be 6 volt. So this is the 6 volt. So if this is 6 volt and ISC I have already calculated that ISC is equals to the 0.714 ampere, then Rn is equals to the VOC divided by ISC, that means VOC equal to 6 and then it will be 7.14, so it will be 6 divided by 7.714, it will be 8.4 ohm. Okay, so this circuit can be transformed in this way. This is the energy source In. So In is equals to 0.714 ampere, and this is the parallel resistance. This parallel resistance Rn equals to the 8.4 ohm. This is the equivalent Norton circuit from this circuit. Okay, so in the next class I will discuss the problem, the circuit containing independent energy source. Hello friends, today we will discuss about these two problems. Here you see, these two problems are similar to each other. This problem contains two energy source. This problem also contains two energy source. Here you have to calculate this branch current. Here you have to calculate this branch current. So both the problems are similar to each other. So what is the procedure to solve this type of problem? We have to know. In earlier class we have already discussed about KCL, KVL, Kirchhoff voltage law, Kirchhoff current law, Thevenin's theorem, Norton's theorem. But all these theorem, if you want to apply all these theorem to calculate this branch current, you cannot solve easily. So you have to know a theorem. By using this theorem, we can easily calculate this branch current or branch voltage, any branch current or branch voltage. What is this theorem? This theorem is superposition theorem. So we have to know about superposition theorem. By using this theorem, we can easily calculate any branch voltage or branch current when circuit contain more than one energy source. So what is the superposition theorem? Suppose this is a network. This is a network. This network must be a linear network. It should be a bilateral network. Bilateral network. So in this network, suppose you give the input, suppose x1, then its response or output is suppose y1. So when you give input x1, then its response is y1. Now if you give the input x2 in this network, x2, suppose this output is y2. Suppose this output is y2. Now if you want to give both the input x1 and x2 simultaneously in this network, so when you give both the input simultaneously in this network, then what will be the output of this network? So superposition theorem gives this idea what will be the output of this type of network when you apply more than one input. So according to superposition theorem, its output will be y1 plus y2. That means algebraic sum of y1 and y2. So what is the statement of this superposition theorem? The statement of the superposition theorem is, if a number of voltage or current source are acting in a linear bilateral network, then the current or voltage in any branch, current or voltage in any branch is the algebraic sum of current or voltage due to individual energy source by replacing with their internal impedance. This is the statement. So what is this statement? The statement is, if a number of voltage or current source are acting in a linear bilateral network, then the resultant current or voltage in any branch is the algebraic sum of the current or voltage due to individual energy source by replacing with their internal impedance. Okay, this is the statement of this superposition theorem. So using this theorem we can easily solve this problem. So what is the procedure to solve this problem, we will discuss here. So this is the problem 1. Problem 1, when you replace current source, then it will be open circuited because current source contain infinite resistance. When you replace voltage source, then it will be short circuited because voltage source contain small amount of resistance. Okay, so here this problem, so you have to calculate current due to 4 ampere current source, and here you have to calculate current due to this voltage source. So number 1, current due to 4 ampere current source. So when this circuit is redrawn, then what will be the circuit? This is 4 ampere current source, and this is resistance 2 ohm, and this is resistance 2 ohm, and these voltage source are short circuited. This voltage source is to be short circuited. This is be short circuited. Okay, because the internal resistance of this voltage source is very negligible, it's very small. So in this case, what will be the current of this branch? This is short circuited, so this current is divided through this resistance and through this resistance by using current division rule. So using current division rule, you can calculate I1. What will be the I1? I1 is 2 divided by 2 plus 2 into I, that means 4 ampere. So it will be 2 by 4 into 4 ampere, so it will be 2 ampere. So the current through this branch due to this current source is 2 ampere. Now you have to know what will be the current due to this 20 volt resistance. So number 2, so current due to 20 volt current source, okay, voltage source. So if you redraw this circuit, it will be, this is a current source, this is 2 ohm resistance, and this is 2 ohm resistance, and this is 20 volt, this is plus, this is minus 20 volt, and this is current source. That's why it should be open circuited, because current source contain infinite internal resistance. That's why it is open circuited. This is 2 ohm. So no current will pass through this branch because this is open circuited. So current through this resistance 2 ohm, it will be I2 will be 20 divided by 2 plus 2. So it will be 4. So it will be 5 ampere. Now using superposition theorem, so current I using superposition theorem, you can calculate I equals to I1 plus I2. So it will be 2 plus 5 equals to 7 ampere. So here the answer will be 7 ampere. So I will be 7 ampere. Now if you reverse this sign, if you give the minus sign here and plus sign here, then it will be minus 5 ampere. Okay, so due to this 4 ampere current source, there will be a 2 ampere current in this resistance. If you reverse this sign, then the current will pass through this 5 ampere. So if you take 2 ampere as a positive, then 5 ampere must be a negative. In that case, it will be minus 3 ampere. It will be minus 3 ampere. Okay, if you reverse this sign. Now second problem. So this is the procedure how to solve this type of problem. Now second problem. Here you see, you have to calculate current due to this 3 volt current voltage source. So current due to 3 volt voltage source. So you have to redraw this circuit. So this circuit will be, this is 3 volt plus minus, so it is 4 ohms, and this current source will be open circuited because current source contain infinite resistance, internal resistance. So here the current I1, suppose this is I1, so the I1 will be 3 divided by 4 ampere, because there will be no current pass through this branch, all current will pass through this 4 ohm resistance. So here is I1 equals 3 by 4 ampere, so it will be 0.75 ampere. Okay, so now current due to 0.25 ampere current source. So here this I1 is given, direction is given in this direction, and here is in this direction. So this current will be I1 plus 0.25 ampere, because current due to this current source. So if you redraw the circuit, so this circuit will be in this fashion. So this is current source 0.25 ampere. This is 4 ohm. So here it is short circuited. It is short circuited. So current will pass through this junction because this is 4 ohm resistance and here is no resistance. So current will pass through this resistance, no current will pass through this 4 ohm resistance. This current will totally pass through this resistance. So here this current is suppose I2. So I2 must be 0.25 ampere because no current will pass through this 4 ohm resistance, because there is another path parallel to this 4 ohm resistance is resistanceless. Okay, that's why I2 is 0.25 ampere. Now using superposition theorem, you can say that I equals to I1 plus I2. So it will be 0.75 plus 0.25. So it will be 1 ampere. So current through this 3-volt energy source is 1 ampere. So in this way we can solve this type of problem using superposition theorem. In next class I will solve another 3 or 4 problem related to superposition theorem. Hello friends, today we will discuss about these 2 problems. Here you see you have to calculate this branch current and here you have to calculate this branch current through 4 ohm resistance. Here this problem contain 2 energy source, this problem contain 3 energy source. Both the cases you have to calculate the branch current, and here you see both these problem contain more than 1 energy source. So when a circuit contain more than 1 energy source, then by using superposition theorem you can calculate any branch current or branch voltage. So let's start. Here is problem number 3. So number 1, you have to calculate current through this branch due to 10 ampere current source. So current due to 10 ampere current source. Okay, so you have to redraw this circuit. So when this circuit is redrawn, so it will look like this is 10 ampere current source and this is node A. So this is resistance 2 ohm resistance and this is 2 ohm resistance and this is 4 ohm resistance and this is voltage source. Now this voltage source contain very small internal impedance, that's why it is must be short circuited. So this is short circuited. Now you have to calculate this current. Suppose this current is I1. Now this 10 ampere current will divided in this node A. Some current will pass this through this 2 ohm resistance, some current will pass through this resistance. Now when this current I1 come this node B, here total current will go through this short circuited path. No current will pass through this 4 ohm resistance. So for this reason, this 4 ohm resistance can be neglected for calculating this I1. Okay, so when this I1 is divided by 2 paths, this path contain no resistance, this path contain 4 ohm resistance. That's why no current will pass through this 4 ohm resistance. Total current will pass through this short circuited path. So using current division rule, you can calculate this I1. So what will be this I1? I1 will be 2 divided by 2 plus 2 into 10 ampere. So it will be 5 ampere. So in this case, this I1 is 5 ampere along this direction. Okay. Now number 2, current due to 20 volt voltage source. Now in this case, this circuit is to be redrawn. So what will be the circuit? This is current source and this is node A. This resistance is 2 ohm resistance, this resistance is 2 ohm resistance, this is B node, and this is 4 ohm resistance, and this is voltage source. This voltage source is 20 volt plus minus. Here this is a current source. So current source contain infinite internal resistance. That's why this must be a open circuited. So no current will pass through this path. So this is open circuited. So total current, suppose this is total current, this current will pass through these 2 branch. Suppose this current is I2 and this current is I dash. Okay, and this current is I. So what will be the I? I can be calculated as, this is 20 volt resistance, 20 volt. So 20 volt divided by equivalent resistance across this path. What will be the equivalent resistance across these 2 terminal? This is 2 plus 2 are in series, and this series are parallel with this 4 ohm resistance. So it will be, so this resistance are in series, so this will be 4 ohm. This 4 ohm and this 4 ohm are in parallel. That's why this current is 4 parallel 4. This is ampere. So this will be 20 divided by 4 into 4 divided by 8. So it is 2. This is 2. So it will be 10 ampere. Okay. So this current is 10 ampere. Now what will be the current I2? By using current division rule, this I2 is given by, this is 4 ohm resistance, this is combined resistance 4 ohm. So this current will divided by same amount. So using current division rule, you can calculate that this is 4 and this is 4. So 4 plus 4, okay, into this I. This I is 10 ampere. This is this I, this 10 ampere. So this current will be, this is 4, this is 4 for 8. So 4 divided by 8. So it is 2 into 10 ampere. So this is 5 So this is 5 ampere. And direction of this current is along this direction. Here is current is along this direction. So if you take this is positive, then it must be negative. So using superposition theorem, you can calculate this branch current I equals to I1 plus I2. So this is 5 ampere minus 5 ampere equals to 0 ampere. So current through this along this direction is I2 is minus 5 ampere. So total current of this branch is 0 due to two energy source. So superposition theorem, according to superposition theorem, the branch current is the algebraic sum of the resultant current due to these two individual current source. Okay, so this is the problem number 3. Now I will solve problem number 4. Problem 4 is more complex than 3 because this problem contains 3 energy source. So I will solve step by step. So problem number 4. So step 1, I want to calculate the current due to this 5 ampere current source. So current due to 5 ampere current source. So this circuit can be redrawn in this fashion. This is voltage source, this is 2 ohm resistance. Suppose this terminal is called A and this terminal is suppose B, node is B. So suppose this is B node and this is a current source. This is a current source. This is resistance 3 ohm. This is resistance 4 ohm and this is and this. Now in this case this is 10 ohm resistance, 10 ampere current source, and this current source is 5 ampere current source, 5 ampere current source, and this is 2 ohms. This is 2 ohms. So here this 20 volt voltage source is must be a short circuited. So this is short circuited, and 10 ampere current source must be open circuited. This is A terminal, this is B terminal. So this terminal all are same. So if I redraw this circuit again, then suppose this is A, this is A terminal. Okay, this is A terminal. Suppose this is B terminal. From A to X, this is X terminal. Suppose this is X terminal. Okay, from A to X there is a 4 ohm resistance. This is 4 ohm resistance. Okay, now from A to B this is 3 ohm resistance. This is 3 ohm resistance. From A to X there is a 2 ohm resistance. It must be a 2 ohm resistance. Now B to X there is a 2 ohm resistance. So B to X this is 2 ohm resistance. Okay, A to X, A to X to B, and this is 3, this is 2. Okay, and another path is short circuited, and B to X B2X, this is a current source. This is current source 5 ampere. So this circuit is written here. Now this you have to calculate this current through this 4 ohm resistance. Okay, so this 5 ampere current will divided from this node. So this portion equivalent resistance, this equivalent resistance is this equivalent resistance will be 2 are parallel, and with this parallel portion it is series. So this is 3 plus 2 parallel 4, 2 parallel 4. So it will be 3 plus 2 parallel, that means 2 into 4, 2 plus 4. So it will be 3 plus 8 divided by 6. So 4, this is 3. So it will be, this is 3, and it will be 3, 3, 9, 9, 10, 11, 12, 13. It will be 13 by 3, 13 by 3 ohms. So this equivalent resistance of this portion is 13 by 3 ohm resistance. Now using current division rule, you can calculate this current. Suppose this current is I dash. Okay, so I dash will be, this is 2, so this is 2, 2 plus R equivalent. Using current division rule, the current through this branch I dash, so I dash can be calculated by using current division rule. What is the current division rule? This is 2 divided by 2 plus R equivalent. Okay, so here this is 2, this is 2 plus equivalent means 13 by 3 multiplied by 5 ampere. Okay, into 5 ampere. So it will be 2 divided by 6, that means 19 by 3 into 5 ampere. So it will be 2 into 3 by 19 into 5 ampere. So 30 by 19, 30 by 19. So it will be 13 by 19. Okay, here is 5, this is 2 plus 13 by 3, so it will be 6 plus 13, that means 19 by 3, this is 2, so it will be 30 divided by 19 ampere. Okay, now what will be the current I1 through this 4 ohm resistance? Now using current division rule, you can calculate this current I1. So I1 is given by, this is 4 ohm, this is 2 ohm. So 2 divided by 2 plus 4 using current division rule, I dash, this is I1. Okay, so I1 is going through this 4 ohm resistance, and here is 2 ohm resistance. So by using current division rule, you can calculate I1. So I1 is 2 by 2 plus 2 into this current, this is 30 divided by 19 ampere. So it will be 2 divided by 6 into 30 divided by 90 ampere. So it will be 5. So 10 by 19 ampere. So current due to this 5 ampere current source is 10 by 19 ampere along this direction. So I1 is along this direction is 10 by 19 ampere. So this is the first portion. Now current due to second current source, this current source. So number 2, current due to 10 ampere current source. So this circuit will be in this fashion. So this is 2 ohm resistance, okay, and here this is 1 ohm resistance. This is B branch. This is 3 ohm resistance. This is 4 ohm resistance. This is current source. This is voltage source, and this is current source. This current source is 10 ampere along this direction, okay. This is a portion. Now this is short circuited, this is open circuited, okay. Now this circuit can be written as this are all are x terminal. So suppose this is A, this is B, and this is x terminal. So from A to X there is a 4 ohm resistance. So suppose this is 4 ohm resistance. A to B, this is 3 ohm resistance. This is 3 ohm resistance, okay. A to B, there must be a 10 ampere resistance. So here this is 10 ampere resistance, 10 ampere current source. So you can draw in this fashion, okay. You can draw in this fashion. How to draw? You draw in this way. A to B, suppose this is B, this portion is B, and here is A, this portion is A, okay, A and B. So from A to B there is a current source 10 ampere. This is A, this is A, this is B. A to B there is a 3 ohm resistance. This is 3 ohm resistance. So this is 3 ohm resistance. A to X is 4 ohm resistance. A to X, suppose this is X, this is 4 ohm resistance. This is 4 ohm resistance, okay, 4 ohm resistance. This is A. From A to X there must be A to X there is 2 ohm resistance, 2 ohm resistance, from B to X, this is a 2 ohm resistance. This is 2 ohm resistance. So here you have to calculate this current. This is I2, suppose I2. Okay, this is 3 ohm, this is 10 ampere, and this is 2 A to X, 2 ampere, 2 ampere, and is another 2 ampere B to X. Okay, now you have to calculate I2. This current will pass in this way. Okay, so using current division rule, you can calculate this current. Okay, this current is here. This R equivalent is these two are parallel, 4 and 4. So 4 parallel 4, 4 parallel 2, 4 parallel 2 with series with 2. So here this will be 4 into 2 divided by 4 plus 2 plus 2. So it will be 8 divided by 6 plus 2, 4, 3. So it will be 10 divided by 3 ohm resistance. So equivalent resistance of this portion is 10 by 3. 4 parallel 2 plus 2 plus 2. Now this is 2 plus 4 plus 2, 4 multiplied by 2, so 8, 6, so it will be 10 by 3. Now this current, suppose I2 dash. So I2 dash can be calculated by using current division rule. So this I2 dash can be calculated. This is 3, so 3 divided by 3 plus R equivalent multiplied by 10 ampere. So it will be 3 divided by 3 plus 10 by 3 into 10 ampere. So it will be 3 divided by 9, 19 by 3 into 10 ampere. So it will be 9, 3 into 3 by 19 into 10 ampere. So it will be 90 divided by 19 ampere. This current, this I2 dash is divided in two paths, this path and this path. This I2 can be calculated as by current division rule. So what will be this current through 4 ohm resistance? It will be 2 divided by 2 plus 4 into I2 dash. This is I2 dash, 19 by, so it will be 2 by 6 into 19 divided by 90 by 19 ampere. So it will be 15, so it will be 30 divided by 19 ampere. Okay, so due to 10 ampere resistance, 10 ampere current source, the current is through A. So from this region, I2 is along this direction, the value is 30 divided by 19 ampere. Now due to 20 volt voltage source, current due to voltage source. Now number 3, current due to 20 volt current source. So for this region the circuit will be look like this. So this is 2 ohm resistance, this is 2 ohm resistance, or this is 2. Here all the cases we have taken is this is 2. Okay, this is 2. All the cases we have taken is this is 2 ohm resistance, this is 2 ohm, this is 2 ohm. So this is B, this is 3 ohm resistance, this is current source, this is voltage source, this is 20 volt, and this is also a current source, this is 4 ohm resistance. This is open circuited, this is open circuited. So you have to calculate this current. What will be the current? Current can be calculated as this current I can be calculated as this is, these two are in series with this portion are parallel and with this are series. So I can be calculated as 20 divided by 2 parallel 2 plus 3, and these are in series. So it will be 20 2 parallel 5 plus 4. So this I will be 20 divided by 2 multiplied by 5, 2 plus 5 plus 4. So it will be 20 divided by 10 divided by 7 plus 4. So this is be 20. So it will be 7, 28, I mean 38. So it will be 20 multiplied by 7 by 38. So it will be 10, this is 19. So 70 divided by 19. Okay, and this direction are along this direction. So using superposition theorem, current through this branch I is I1 plus I2, and this is suppose I3. Okay, so plus I3. If we take in this direction as a positive and in this direction as a negative, then it will be 10 17 by 19 minus 30 by 19, 30 by 19 minus 10 by 19. Okay, so it will be 19 70 minus 30 minus 10. So it will be 70 minus 40 by 19, that means 30 by 19 ampere. So in this way you can solve this type of problem. We will discuss about this problem. This problem contains several number of resistance and two energy source, one voltage source, one current source. In this problem, you have to calculate the value of R in which the circuit transfer maximum power to this load. So, to solve this type of problem, you have to know what is the condition for transferring maximum power to the load by the network. So, to calculate this condition, we have taken this circuit. So, this circuit contains input impedance, source impedance, that means ZS. So, source impedance ZS can be written as RS plus its reactive parts, and the load impedance ZL can be written as RL plus J of XL. That means this is resistive part and this is reactance part of the source impedance and its load impedance. Now, this is a current flowing through this circuit I. So, I can be written as I equals to ES divided by ZS plus ZL. If I put this value, then it will be ES divided by RS plus RL plus J into XS plus XL. So, this is the current flowing through this network. Now, we want to calculate the condition for maximum power transfer to the load. That's why we have to calculate the power through this power in this load resistance, power developed in this load resistance. So, current flowing through this load resistance is I. So, power P can be written as I square into RL. So, it will be ES square into RL divided by RS plus RL square plus XS plus XL square. This is equation number 2. So, this is the power in this load resistance. Now, this variable power will be maximum when del P by del RL must be 0. So, this power will be maximum when del P by del R will be 0. So, we put this condition into this equation number 2. So, if I take the partial derivative of this power P, then it will be in this way. The main formula is, suppose this is partial derivative, so this is x suppose, so this is suppose fx term, this is gx term. So, you want to derivative this function in this way. So, it will be the formula gx whole square and it will be fx first derivative into gx minus gx into gx first derivative into fx. Okay, this is the formula. Using this formula, we can get this derivative del P by del L. So, this is the function G, and this is the function f. Okay. So, it will be this. So, rs plus rl whole square plus xs xl whole square and this all whole square using this formula. Okay, now first derivative of this fx. So if I derivative f this term with rl, so it will be es square and this term will be remain same, so it will be rs plus rl whole square plus xs plus xl the whole square. This is the first term minus this function will remain same and this function will be first derivative. So this function is es square into rl. If I derivative this function, then it will be 2 into rs plus rl into 1 and this term is will be 0, so is equals to 0. Now here is e square, here is e square, so e square will be common from both sides, so it will be e square. Here is rs square, rs plus rl whole square here will be only 2 into rl, rs plus rl must be equals to 0. This term will be 0. Okay, so next this term cannot be 0, that's why this term will be 0. So here this and this term, if we take this rs plus rl whole square, it will be minus if I here is rs square plus 2 into rs into rl plus rl square. From this here it will be 2 rl into rs and here will be minus 2 rl square and this term will be x plus xl whole square equals to 0. So here is this term and this term will be cancel out. For this reason here will be rs square and this is rl minus 2rl, so minus rl square plus xs xl whole square equals to, you can write that, so resistive part plus j into, that means 0. Okay, so this term is resistive part and this term is reactance part. This is a resistive part and this is reactance part. Okay, so from this equation we can easily write that from this equation the resistive part must be equals to 0 and reactance part must be equals to 0. So from this equation we can write that rs square minus rl square equals to 0 and xs plus xl whole square equals to 0, because resistive part must be equals to 0 and reactance part must be equals to 0. So from this equation you can write that rs equals to rl. That means this is condition number, suppose this is equation number 3. From this equation you can write that xs plus xl equals to 0, so xs equals to minus of xl. So from zl equals to rl plus j into xl. So from this equation rs equals rl equal to be rs, so this is rs, and this is minus of j into xs. So you can write that the complex conjugate of zs equals to complex conjugate of zs. Okay, so here I have reduced this condition that the load impedance must be equals to the complex conjugate of source impedance. What is the condition for maximum power transfer by this network? It will be the load impedance must be equals to the complex conjugate of the source impedance. Now you have to state that what is the maximum power transfer theorem. Maximum power transfer theorem states that the maximum power is delivered by this network to this load when the load impedance is equals to the complex conjugate of the source impedance. This is the statement of maximum power transfer theorem. So number 1 condition is ZL must be equals to complex conjugate of source impedance. Okay, source impedance. This is the condition number 1. Now condition number 2. This load impedance, suppose this is source impedance rs plus j into xs. So this term is jxl and this is a resistance part rl. This rl is variable and this is constant. So number 2, when rl is variable and reactance part is constant, then what will be the condition for maximum power transfer theorem? What is the condition? Condition is RL, that means ZL must be equals to, or RL, this is RL, variable is RL, must be equals to the ZS plus J into XL. Okay, so here it will be RS plus J into XS plus XL. If you get this magnitude, so it will be RL square equals to RS square plus XS plus XL whole square. So if the circuit contain variable resistance but constant reactance, then what will be the condition for maximum power transfer theorem? The RL square must be equals to RS square plus XS plus XL whole square. This is the condition for this circuit. Now condition number 3. Now if the circuit contain the variable resistance, that means this circuit, suppose this circuit contain variable resistance, load resistance, only variable load resistance, no reactance. This is variable RL. Then what will be the condition for maximum power transfer theorem? Maximum power transfer theorem, it will be RL square must be equals to RS square plus RXS square. Okay, if Xs equals to 0, then RL equals to Rs. So this is the three condition for maximum power transfer theorem I have reduced here. Now I will solve this problem using this fundamental theorem of maximum power transfer theorem. This problem contains several number of resistance. You have to calculate the resistance R in which this circuit or network give the maximum power to this resistance R. So condition is R must be equals to the RTH or R equivalent seen across the AB terminal. This is AB terminal. So this terminal, this resistance R equivalent equals to RTH, thevenin voltage, thevenin resistance. So this resistance seen across the terminal AB will be equals to the value of R. Okay, the value of R. So you have to calculate the value of R. Now if I redraw this circuit to calculate the RTH, so here is voltage source, this is a resistance 10 ohm resistance, and this is a 40 ohm resistance, and this is a current source, and this is a resistance 8 ohm. This is the terminal A and B. You have to calculate the equivalent resistance, that means RTH is equals to R equivalent seen across the terminal AB. Now to calculate this RTH or R equivalent seen across this terminal, this voltage source must be equals to short circuited. This is short circuited, and this must be open circuited. Current source must be open circuited. So RTH or R equivalent seen across the terminal AB must be equals to this, both are parallel and this is series. So 8 plus parallel 10 and 40. So it will be 8 plus this parallel means 10 multiplied by 40 divided by 10 plus 40. So it will be 8 plus this is 10 multiplied by 40, this is 50. Okay, so it will be cancel out. So here it will be 5, this is 40 plus 40 plus 40. Okay, 40 plus 40. So it will be 80 divided by 5 ohms. So it will be 16 ohm. So value of R must be equals to the value of RTH or R equivalent. So it will be value of R must be equals to 6 ohm. So using maximum power transfer theorem, you can easily calculate the value of R when this circuit or network give the maximum power to this resistance R. The value must be equals to 16 ohm. Okay, so in next class I will discuss several number of problem related to maximum power transfer theorem. We will discuss about this problem. In this problem, you have to calculate the change in current through this branch when the resistance R is changed from 2 ohm to 6 ohms. That means change of resistance of this branch is equals to 6 minus 2, that means 4 ohms. So what will be the change in current through this branch when the change in resistance is 4 ohms? So how to calculate this change in current? By using compensation theorem, we can easily calculate this change in current due to change of resistance. So first of all, we should know what is the compensation theorem. Here we draw two network. This simple network contain two resistance and one voltage source. So from this network we can say I is given by V divided by R1 plus R2. Now this resistance is increased by amount del R. Then the resistance current through this network is I dash. So I dash must be equals to V divided by R1 plus R2 plus del R. So due to change of this resistance R2 by amount del R, the change in current del I is equals to I minus I dash. So you have to calculate this current by using compensation theorem. So what is the compensation theorem? Compensation theorem states that in a linear bilateral time invariant network, if the resistance of any branch of a network is changed by amount del R, then the current through all the branch of this network will change, and the amount of change in current through any branch can be calculated by replacing a voltage source Vc such that Vc equals to I into del R in series with resistance R plus del R. So if I replace this network using compensation theorem, so it will be like that. This is resistance R1 is same. Now this resistance R2 is replaced by R2 plus del R with series with a voltage source Vc such that I into del I. So here is I is this I. So here is voltage source is Vc equals to I into del R, and this voltage source must be short circuited. So this is short circuited. So according to compensation theorem, the change in current, so this is del I. So change in current through any branch of a network can be calculated or can be found out by replacing a voltage source Vc equals to I into del R with series a resistance by R plus del R. Okay, and what is the I? I is the current of the when the when the resistance is not changed. So this current, okay, when the resistance is not changed, at this condition this is the current. And to calculate this change in current, the voltage source must be short circuited. This is the equivalent circuit to calculate the change in current by using compensation theorem. So from this network we can say that change in current is equals to Vc divided by R1 plus R2 plus del R. That means I into del R, divided by R1 plus R2 plus del R. This is the compensation theorem. So using this compensation theorem, we can calculate this change in current through this branch when the resistance R is changed from 2 ohm to 6 ohms. So now I will solve this problem using this compensation theorem. So for this case you have to calculate the current, first current when the resistance is 2 ohm. So you have to first calculate this I. So suppose this current is I dash. So to calculate this I dash, you have to know the equivalent resistance from this point, source point. So this is R equivalent, suppose. Okay, so what is the current I1? I1 can be calculated as 2 volt, that is V divided by R equivalent. So R equivalent can be calculated, this is 2 volt divided by these two resistance are in series. That means it will be 2 plus 2 parallel 4. Equivalent resistance from this source point, these two resistance are parallel to each other, and with these 2 ohms these are in series. So 2 plus 2 parallel 4. So it will be 2 plus multiplication by summation, that means 8 divided by 6. Upper front will be multiplication and this is summation. So it will be 2 divided by 6, 20. Okay, so it will be 2 into 6 by 20, that means 10. So it will be 3, 5. So 3 by 5 ampere. Okay, so I dash is 3 by 5 ampere. Now we have to calculate I. What is the I? I can be calculated by using current division rule. This is 2 branch, and this current I have already calculated that this is 3 by 5 ampere. This is 3 by 5 ampere. Now you have to calculate the current through this 2 ampere. So by using current division rule, we can calculate this I. So I is given by 4 divided by 2 plus 4 into I dash. Okay, so it will be 4 divided by 6 into, this is 3 by 5. So this is 2, so this is 2, so it will be 2 by 5 ampere. So I is 2 by 5 ampere. So this current is 2 by 5 ampere. Now you have to apply compensation theorem. So how to apply this compensation theorem to this network? Compensation theorem states that the voltage source must be short circuited. So this is voltage source, this is short circuited. Okay, the resistance 2 ohm are in same, so this 2 ohm resistance is equals to 2, and this 4 ohm resistance must be as the same, so this is 4 ohm resistance. Now this resistance will be 6 ohm because del R equals to 4 and the R plus del R plus del R is equals to 6, because this is 2 and change of current is 4, so it is 6. So this resistance is 6 ohm, and with this 6 ohm the voltage source Vc is equals to I into del R, I into del R. This is the equivalent network by using compensation theorem. So what is the Vc, amount of Vc? So Vc is given by I into del R. So I is 2 by 5, so 2 by 5 multiplied by change in current is equals to 4, change in voltage resistance is 4, so it will be 8 by 5 volt. So it is 8 by 5 volt, 8 by 5 volt. This is plus minus. Okay, this is 8 by 5 volt. Now this circuit can be redrawn as these two resistance 2 ohms and 6 ohm are in parallel. These point are in same, so this circuit can be redrawn as, suppose this is Vc, this is Vc, so this is Vc, Vc is 8 by 5 volt, and now this resistance is 6 ohm, 6 ohm. Now these two resistance are in parallel, so it can be redrawn as this is 4 ohms suppose, and this is 2 ohms, this is 2 ohms. So this is the change in current, this is del I, this is del I. Now we can redraw this circuit as this is voltage source 8 by 5 volt. Now these two resistance are in parallel, so these two resistance are equivalent to this equivalent resistance is 2 multiplied by 4 divided by 6, so it will be 8 by 6, that means 4 by 3, so it is 4 by 3 ohms, and this is 6 ohms. So current is del I. So del I is given by, this is 8 by 5 volt divided by 6 plus del 6 plus 4 by 3, 6 by 4 by 3. So it will be 8 by 5 divided by, this is 3, so 22. This is 22. So from this we can write that 3 by 22, so it will be 411. So it is 12 by 55 ampere. Okay, so change in current through this resistance is 12 by 55 ampere. So in this way we can calculate the change in current through any branch of a network when the resistance R is changed by del R. Okay, we will discuss about this problem. These two networks contain same resistance. Here you see, this is R1, this is also R1, this is R2, this is R2, this is R3, this is R3, this is R4, this is R4. So all the resistance are same and similar to each other. Now in this network, this is the voltage source, but in this network here is this voltage source. For this voltage source 10 volt, you have gotten that 2 ampere current at this position. Now you have to calculate the current at this position of this network when the voltage is changed from this position to this position. Okay, so in this case you have seen that only the voltage source is changed. That means if I take, this is a excitation, this is excitation of this network, and this is the response, this is the response. Okay, so only in these two network the excitation and response are interchanged. This is response and this is excitation. So both this network, the excitation and response are interchanged, but all the remaining part of this two network are in same. Now what is the current of this position? That is, what is the value of this current I? To calculate this current I, you have to know reciprocity theorem. What is the reciprocity theorem? So using reciprocity theorem we can easily calculate this current I. What is the reciprocity theorem? Reciprocity theorem states that in a linear bilateral single source reciprocal network. So in a linear bilateral single source and reciprocal network, the ratio of excitation to response must be constant when all the resistance are in same by magnitude and position. Okay, so this is the reciprocity theorem. So here is this, if I apply this reciprocity theorem in this network, so in this case the excitation is 10 volt and response is 2 ampere. So the ratio is 2. Now in this case the excitation is 20 and this is I, it must be equals to 2 because the remaining part of this network are same. That's why we can apply this reciprocity theorem. So in this case, so it will be excitation, this is 2 not 5, so it will be 5, so it must be 5. Okay, this is response is 2, so excitation to response is equals to, it will be 5. So in this case the excitation divided by the response must be equals to 5. So in this case I is equals to 20 by 5 equals to 4 ampere. Now you have to calculate the direction of the current from this source. So current must be equals to in this direction, not in this direction. So due to the position or polarity of this voltage source, the current must be equals to in this direction, not in this direction. So current, it will be minus 4 ampere. So this is the reciprocity theorem. By using reciprocity theorem you can solve in this type of this problem. So today we will discuss about this problem. In this problem you have to calculate this current I through this resistance 2 ohms. So how to calculate this current easily? So to calculate this current I easily, you have to know about Millman's theorem. So what is the Millman's theorem? Suppose this is a network. This network contains a voltage source V1 with internal impedance Z1 and voltage source V2 with their internal impedance Z2 and so on. They are connected in parallel with their common load ZL. Millman's theorem states that this arrangement can be replaced by a single voltage source VEQ and connected with series equivalent impedance ZEQ, and this is the ZL, such that VEQ must be equals to V1 Y1 V2 Y2 plus so on V2 Vn Yn, and this is Y1 plus Y2 and so on Yn, where Y is the admittance, so Y equals to 1 by Z. So it can be written as summation of Vn Vi Yi, where I equals to 1 to n, and this can be written as summation of I Yi, where I equals to 1 to n, and ZEQ is given by 1 by Y1 plus Y2 plus Yn. So it can be written as 1 by summation of Yi, where I is equal to 1 to n. So this is the Millman's theorem. So if several number of voltage source with their internal impedance are connected in parallel with their common load impedance ZL, then Millman's theorem states these types of arrangement can be replaced by a single voltage source VEQ such that VEQ equals to this is connected with series equivalent impedance ZEQ such that ZE equals to this. Okay, so this Millman's theorem can be applied here to calculate this current I. So now I will solve this problem using Millman's theorem. Okay. Now this problem contains two voltage source. So I have redraw this circuit. So this two voltage source, so this is one voltage source 2 volt, this is plus, this is minus with impedance 1 ohms, and this is another voltage source 4 volt with their impedance 2 ohms. Now this portion is a current source. This portion is contain current source. So to apply Millman's theorem, you have to convert this current source into a voltage source. So by converting this current source into a voltage source, you can convert it as this voltage source can be converted as V equals to I into R. This is voltage 1, so this is resistance 5, so this is 5, so equals to 5 volt. So this is plus, this is minus, this is 5 volt, and this resistance will be series with this voltage source, so it will be 5 ohms. So this portion is converted into a voltage source with series impedance 5 ohms. Now this is a resistance I, this is I, and this is the resistance 2 ohms. Okay, so now we can apply the Millman's theorem in this circuit. Okay, now Millman's theorem. Now this circuit now converted as a single voltage source. So what will be the single voltage source? This is VEQ, and this must be ZEQ, and this is 2 ohms. This is 2 ohm. This is current I. Now what is the VEQ? VEQ equals to V1 Y1 plus V2 Y2 plus V3 Y3 divided by Y1 plus Y2 plus Y3. So what is the V1? V1 is 2 divided by 1. So 2 by 1, because this is Z, so Y equals to 1 by Z. That's why that is 2 volt divided by 1. Now this is 4 volt, this is 4 volt divided by 2, and this is 5 volt divided by 5. This is 5 volt divided by 5. Okay, now Y1 equals to 1 by 1 plus this is 1 by 2, this is 1 by 5. Okay, so this can be written as this is 10, so it will be 10 plus 5 plus 2, and this also 10, so it will be 20 plus 20 plus 10, so it will be 10 cancel out, so it will be 50 by 17 volt. So this is plus minus, this is 50 by 17 volt. Okay, now you have to calculate the ZEQ. What is the ZEQ? ZEQ equals to 1 by y1 plus y2 plus y3. So it will be 1 by, that means 1 by 1 plus 1 by 2 plus 1 by 5. So it will be 1 divided by, this is 10, so it will be 10 plus 5 plus 2, so it will be 10 by 17 ohms. Okay, it will be 10 by 17 ohms. So this is 10 by 17 ohms. Now you have to calculate the current I from this equation. So now we can calculate this value. Now from this equation, I can be written as, this is VEQ divided by ZEQ plus 2 ohms. That means it is 50 divided by 70, and here 10 by 17 plus 2. So it will be 50 divided by 70 into 44. Okay, this is 50 by 70, and this is 70 is upper side, and this is 44. So this is 70 is cancel out, so it will be 50 by 44. Okay, so it will be 50 by 44. So if I calculate this, so it will be this is 25 divided by 22. So if I this is 1 point, this is 330, so 1.14, approximately 1.14 ampere. So this current is 1.14 ampere. Okay, so in this way you can calculate this current I using Millman's theorem.